Hello, everyone. Welcome to the first session of this afternoon. I'm Xinyu Chen. I will moderate this session on foundations of agents. So we will have 4 great speakers in this session, including Dong Song, Ed Shi, Sergey Levin, and Jakub Pachowski. So let's start with the keynote from Dong Song on building safe and secure agentic AI.
Okay, great. Thanks everyone. And I hope people who are still coming, please take a seat. And hope everyone had a great session in the morning. So now I'm going to give a keynote talking about towards building safe and secure agentic AI. And as I introduced myself earlier already, I'm a professor in computer science at UC Berkeley and also the faculty co-director of the center Berkeley RDI. Okay, great. So we are all really excited about the fast advancements in frontier AI. And this year has been called the Year of Agents. So at the same time of this exciting advancement, on the other hand, we also need to pay attention to the potential different types of risks. So in our recent International AI Safety Report, led by Yashua Banjo and written by around 100 scholars from 30 countries, we list out a broad spectrum of different types of AI risks. And also I want to stress that in particular, as we deploy AI, it's important to pay attention to consider AI in the presence of attackers for a number of reasons. So first, attacker always follows the footsteps of AI advancement. Does this work? Can we turn this one on? Always follows the footsteps of technology development, or sometimes even leads it. And also the stake is even higher with AI. As AI controls more and more of the system, attackers will have higher and higher incentives to compromise these systems. And also as AI becomes more and more capable, the consequence of misuse AI by attackers will also become more and more severe. And hence, it's really important for us to consider agentic AI in the adversary setting. So the goal is to build safe and secure agentic AI. And largely, the problem falls into 2 main categories that I will briefly overview in this talk. The first one is how we actually build secure agentic AI that can protect the agentic AI systems from different types of attacks. And the second one is mitigating misuse of AI by attackers. And in particular, here I will focus on one particular domain, which is cybersecurity. So I will talk about the mitigating misuse of AI, in particular, impact of frontier AI on the landscape of cybersecurity. So first, I will talk about how we can build secure agentic AI and protect agentic AI from different types of attacks. So agentic AI systems can be fairly complex. The agents is guided by the LM and can interact with the environment to perceive the environment and to do planning and plan for actions and so on, and then take actions in the environment. And agent safety and security is a very complex topic. So first, already itself actually has a lot of safety and security issues. And these safety and security issues get even more further amplified in the agentic setting. So in this talk, given the interest of time, I actually won't have time to talk about at the LM level the safety and security issues. I welcome you to watch my keynote at iClear this year, which focuses on LM safety and security issues at the model level. And in this talk, I will focus more on the safety and security issues for LM agents, the overall agentic AI systems. So when we talk about LM agents, it's actually not just one thing. Actually, LM agents has a very broad design spectrum. For example, all the way ranging from simple chatbots, static workflow, and also fully dynamic workflows and control flows. And also, actually, there are many different dimensions for this overall complex LM agent design space, all the way including the degree of flexibility in workflow, in input space, action space, tools they use, how they handle memories, the degree of autonomy, and user interface, and so on. And one thing I want to note is that as we increase the agent flexibility, this will also, unfortunately, increase attack surfaces. As the agent can use more diverse tools, and they have full autonomy and so on, so naturally this actually increases the risks for the agentic AI systems. And also, there are many different attack vectors under different threat models, depending on whether the attacker has access to the agents or has what type of access to the agent's internal and so on. And also, the agent's internal systems as well as the environments, they also present different types of vulnerabilities and security risks to make the whole agentic AI security issues even more complex. And when we talk about agent security, there are a number of different goals, including confidentiality, integrity, availability, and also in the agentic setting, we also have a new goal, which is contextual integrity, to ensure that the agentic AI systems, for example, tool use and so on, are aligned with users' intent and in that particular context. And these security goals can be challenging due to the different types of risks that I listed earlier. To actually achieve these goals. So in order to actually achieve these security goals, to build secure agentic AI systems, we need to develop new solutions. So here I'll briefly mention two categories. One is how do we actually do a systematic evaluation and risk assessment in agentic AI, and the other one is how do we actually develop then effective defenses for agentic AI. So the first one I'll briefly talk about is developing systematic evaluation and risk assessment in agentic AI. Given what I mentioned earlier, agentic AI has very complex risk surfaces and attack surfaces. We need to develop new technologies to evaluate the agentic AI systems for these different types of risks. So here I just briefly mentioned some of the recent work in my group and with collaborators. So this is one example, Agent Poison, which actually develops a new framework to essentially evaluate, in particular, the risks in agentic AI systems with the poisoning actually in the rack system, putting backdoors in the rack system. And this is another example, developing risk assessment, in particular for coding agents for the different types of safety and security risks. And this is our recent work on Agent Visual, which provides an end-to-end red teaming framework and solution for black box AI agents security evaluation. And in particular here, we develop a full black box evaluation framework that uses LM-based solution for black box optimization and smart fuzzing to automatically generate different types of attack inputs that can be injected in the environments that the agents operate in, and using this approach to evaluate how agents may behave under these different types of malicious environments and evaluate their security risks. And here's an example of a demonstration of a real-world web agent where using the Agent Visual system, we automatically generate attacks that can be injected, for example, in online review websites. When the agents actually navigate to these online review websites, reading these maliciously crafted reviews, this can cause prompt injection in the web agents and causing the web agents to actually then visit malicious websites and then later on download, for example, malware and so on. So these are a few examples illustrating how we can actually develop different types of evaluation and risk assessment methods for this agentic AI system evaluation. However, overall, actually, doing agent evaluation and risk assessment is very challenging for a number of reasons. So first, it lacks standardization, and also there is a limited openness to do more open, essentially have an open ecosystem for the community to work together on this evaluation, and also this low reproducibility and so on. So for example, a lot of the recent papers actually it's difficult for others to reproduce the results and so on. So to address these issues, I wanted to briefly mention that we actually have right. So we are launching a new platform, open platform called Agent.it. It's an open platform for agent evaluation and risk assessment that's designed to address the challenges that I just mentioned. Agent.it provides a standardization for essentially different developers building agents, building their own agents, their own environments, and so on, to all actually easily get connected in this open platform, Agent.it platform, and using the current widely adopted open standards such as A2A, MCP, and so on, and provides a unified SDK for all these to connect together. And also provides openness, where the community can contribute public agents, benchmarks, and hosted environments, and so on. And also this allows full reproducibility. When the evaluation is done, everything gets logged, gets traced. So this also enables essentially automatic tracing, multi-level trace logging, and so on. And also the platform is designed to be easy to use. So it's very easy for developers to actually save the developer a lot of time to actually build agents or environments to connect into the system. And we already have a number of a very rich integration already, including different types of web encoding agents environments, and also different types of attack agents, including prompt injection, jailbreak, and so on. And Agent.it supports broad different types of use cases. You can use Agent.it to run agents on popular benchmark for evaluation. You can actually compete, rank your agents on public or private challenges. And you can contribute by developing new benchmarks, environments, and agents to connect it to this open ecosystem and collaborate with others to improve your agents, and so on. And Agent.it supports many different types of scenarios, including single agents and also multi-agents in many different settings. So the goal is, and also the hope for developers, that this will be very easy for developers to use to set up your agents and then to run and evaluate the different settings. And you can launch competitions very easily as well. So we welcome you to go to agentbit.org. You can sign up there. And stay tuned, and also to help contribute. So that's for evaluation and risk assessment. And for defense, Agentic AI defense, I would say, is a huge open challenge currently, given all the complex risk issues that I mentioned earlier. So first, for Agentic AI defense, we need to have, we strongly recommend a set of principles, including defense in depth, least privilege and privilege separation, and also safe by design and secure by design, and ideally to provide privilege secure solutions for agentic AI systems. And given the interest of time, I won't be able to go into all the different types of defenses that we need to actually develop and adopt in agentic AI defense. Overall here, so I list at a high level, essentially we need to develop different type of runtime protection, also different secure design methodologies. We need to have a stronger, develop better access control, and also hardening at different levels of the systems. So again, given the interest of time, I won't be able to go into the details here. So we have an overview paper that's coming out soon that actually goes into detail on this. And here I just want to briefly mention as one example of some of our recent work on, this is an example of Project, which is a programmable privilege control and guardrail solution for LLM agents that can automatically actually generate security policies to help protect agents in different settings. And also I wanted to mention that we have another session specifically for safe and secure agentic AI in the frontier stage in the afternoon as well, and I welcome everyone to check out more there also. And right, so this is the first part on building secure agentic AI. So I want to now quickly go into the second part about mitigating misuse, in particular in the landscape of cybersecurity. So as I mentioned earlier, with agentic AI, there's a broad spectrum of different types of risks that we need to pay attention to. But in particular, I do strongly believe that cybersecurity will be one of the biggest AI risk domains. Attackers have diverse incentives for attacks, and we're already seeing today huge damages from attacks, and increased AI capabilities, in particular in reasoning and coding and so on. They can significantly reduce attack costs and increase attack scale. And also today, we're already seeing that Gen AI has caused order magnitude increase in certain types of attacks, such as social engineering and phishing attacks and so on. So the key question here is, how will frontier AI change the landscape of cybersecurity, given that AI still use nature? So the key question here is, given that AI can help both the attacker side and defender side, who will AI help more, the attacker side or the defender side? So in order to address this question, we need to do systematic investigation for the whole, across all the different stages of a cyber attack, and also looking at its defenses. So with our recent work, we have set out to explore this area to in particular investigate this question. So my group and with collaborators, we were actually the first to investigate about using deep learning for program boundary analysis and vulnerability detection many years ago. And even back then, we showed that deep learning actually can achieve state-of-the-art in certain domains, such as binary code similarity detection and vulnerability detection and so on. And fast forward now with the LM, the AI capability is significantly stronger. So in our recent work, we also evaluated and investigated hundreds of recent papers exploring the current AI capability and impact levels in the different attack stages. So the current work, with our work, it showed that currently, except for attacking humans using phishing, social engineering attacks, and so on, the attacks, the AI capabilities on in the other attack stages are still relatively limited. But however, our recent work shows that this is changing very fast. So in two examples of our recent work, we show that actually now, today, AI agents actually can already be very powerful in cybersecurity space. So one is Bounty Bench, where we developed a benchmark from using real-world bounty tasks. So here from like 40 different actually bounty programs and so on. And our work showed that with the latest model, and even with the relatively simple agents, actually these agents now can solve these some of these real-world bounty tasks, including finding vulnerabilities and patching vulnerabilities as well. So this is in the web application domain. And our work showed that actually agents today, they can actually solve these bounty tasks equivalent of tens of thousands of dollars. So essentially, these agents can already make money by solving these bounty tasks. So that's Bounty Bench. The second one is CyberGym. This is on large scale, real-world, widely distributed open source programs in C, C++, and so on. So we developed the CyberGym benchmark with close to 200 these large-scale open source programs, which have around, the benchmark also includes around over 1,500 known real-world vulnerabilities. So the task is to see whether agents can find these known vulnerabilities, as well as actually whether the agents can find previously unknown zero-day vulnerabilities. So the work showed that actually, again, with the latest models, even relatively simple agents can actually do a lot. They can actually solve close to 20% of these, actually find close to 20% of the previous known vulnerabilities, and also actually can find 0 days. In particular, we discovered 15 0 days, and also a number of CVEs have been issued based on these 0 days already. And the CVEs actually are attributed to CyberGym, which is nice, to these agents. So what I just showed is that AI is improving really fast with the current agents. Already they can, already they have strong capabilities in cybersecurity. And in particular, on the attack side, the question is how can we actually develop better technologies to use AI to more help on the defender side. So there are a number of challenges here. So one is what we call equivalence classes. So whatever we develop in general to improve on the defense side, the same technology can be used to help the attacker side. And also there's natural asymmetry between attacks and defenses that makes it actually make AI to help more help attackers more than defenders. So for example, on the offense side, you only need to find one attack that works, but for the defender, essentially you need to fix all bugs and prevent all attacks to succeed. And in our paper, we analyze also different types of these asymmetries between attacks and defense. And given the importance of this domain, we also recently launched the what we call Frontier AI Cybersecurity Observatory that provides an open platform to have the community to come together to do continuous monitoring of the AI capabilities in cybersecurity space. And we welcome others to join this effort as well. So then one key question is then what can we really do to actually shift this balance to help AI to help defenders more than attackers? And as I mentioned earlier, some of the defense solutions, such as trying to find bugs, are also for this reactive defense where try to detect attacks once attack happens. These actually still can have AI help attackers more than defenders. What we propose here is to actually use the paradigm for proactive defense with the secure by construction, where we can use AI to actually try to build provably secure systems. So many years ago, actually quite a few years ago, my group and with collaborators, we were among the first to actually use deep learning to try to automate theorem proving. And this is a paper with Lyica from OpenAI back then. So back then, we showed that deep learning actually can help automate certain steps in theorem proving, but it was limited. But now, fast forward with the recent advancement in AI, we do strongly believe that we are hitting an inflection point where we can develop frontier AI technologies to actually help with formal mathematical reasoning and automate theorem proving. And you can check out our paper here. And then using this approach, we hope that we can develop agents. Instead of just playing games like Go, we can actually develop proof agents that can automate theorem proving for program verification. And when used in conjunction with program synthesis, we can automatically generate not just code, like today, we can actually generate provably secure code. And for more information, you can, given the interest of time, I won't go into the details, but for more information, you can check out my actual Keynote, as well as my lecture in the Agent MOOC last semester, on a 2-hour lecture on actually building safe and secure Agentic AI. And also, if you are interested in participating more in the efforts for frontier AI impact in cybersecurity, you are welcome to sign up here. We'll be organizing workshops in the near future. And also, I wanted to mention that, thanks everyone for being here. So I mentioned the Agent MOOC. We so far have over 25,000 enrolled, and this fall we'll be starting the next MOOC in the series, Agentic AI. So please, you can sign up there to get more information. With that, thank you.
Yeah, thanks, Don, for the great talk. Our next speaker will be Ed Shi. So Ed Shi is a VP of Research at Google DeepMind, and he has been leading research teams on building large language models and universal assistants. So in this talk, he will discuss about the recent progress of Google Gemini and how we can build the next agent experience upon this foundation model. So yeah, let's welcome Ed to give his talk.
All right, so earlier this morning, the session, Chi Wang, who works in my team, asked the question, what's missing in the agents right now? And I think that's a very interesting question, because how many of you actually have a personal assistant? Like, I'm counting maybe no more than 5 or 6 hands really right now that have. Maybe some of you actually use your husband or wife as your personal assistant. But if you think about this, the world that we're trying to get to from where we are now is, let's say 6 years later, everyone will raise their hand and say that they have a personal assistant. So how do we get there? And I think it's interesting to first do a little bit of historical observation. In 1998, when I was a graduate student, I went to the HCI conference called SIG-Chi, or the Chi conference. And there, Patty Moss, who was at MIT Media Lab at the time, and still there, I believe, and has started a research group called Software Agents. And they were talking about how do we augment humans so that they're more productive. Now, of course, everyone at the time thought that was so futuristic and was very interested in hearing about it, but the reality is that now, 25 plus 2, 27, almost 30 years later, do we actually have personal assistants? We don't. What do we still rely on? What we actually still rely on is these two systems. Now, I want you to pay very close attention to this, because in 1998, if you had made investments in these two different areas, on the System 1, recommender systems, of which the seminal paper was published by my PhD advisor, John Riedel, in 1994 in the CSCW conference, you would have made a boatload of money. If you had invested in 1998 in what was then called Backrub, which became Google, you would have made a lot of money. At this point in time, the internet industry is completely supported by these two systems. Meta's revenue was $160 billion. And Google's search revenue was on the order of about $200 billion. So altogether, close to $500 billion of the internet industry. If you had invested in 1998, I was a poor graduate student, so I didn't. But some of us did, right, in the Valley, would have become obscenely rich. So now the question is, why are you investing now? That's going to be the true agentic future. And I think this question is interesting because, while in the intervening time, I spent a lot of my years at Google, the last 14 years, continuing to improve these two systems. And you know what they're implemented by? They're implemented by functions. More specifically, they're implemented by ranking functions. Now, ranking function turned out to be a very good application of deep learning. However, in 2015, this we already knew about deep learning, that it can do these kinds of functions. You can put in pixels, you can get classification output. It's a lion, not a cat, not a dog. You can put in audio and get output of the speech recognition. In 2010, when cell phone became a lot more pervasive, we were surprised when the phone got it right when we speak to it. Why? Because the word error rate was 25%. Now it's much less than 25%. I think it's below. The word error rate is way below 1% at this point. Now, in 2025, a seminal paper, actually 2014, NeurIPS December, I should say, a seminal paper on sequence-to-sequence learning was published in which it was demonstrated that translation can be done token by token, sequentially. You can put in hello, how are you, as separate tokens, including a question mark, and we'll come back with bonjour, comment allez-vous in French, with the question mark in the appropriate place, right? And if that didn't blow your mind in 2015, you could put in pixels, images, and ask it to caption it, and we'll do it precisely with 2 L's on traveling. And it says blue and yellow and not yellow and blue. Notice in English, we tend to say blue and yellow and not yellow and blue. Why? Because CMYK, because RGB. So it's a language convention to say blue and yellow. And it gets it completely right. In 2015, if you had put in money, personal investment, on this kind of capability, which is why we call it generative AI. It's generative because it generated one token at a time. That's why it was called generative AI. If you had put in money 10 years ago on generative AI, you have seen these papers. I did. I didn't put money in. How many of you invested in NVIDIA in 2015? Please raise your hand. You were smarter than me, right? That was what was going on in 2015. If you had realized it, you would be easily a millionaire by now, if not double-digit millionaires, right? So what is going on? What happened after the invention of sequence-to-sequence learning and generative AI and transformers? By the way, the three authors of sequence-to-sequence learning were Ilya Sutskever, chief scientist at OpenAI, no longer, unfortunately, Oriol Van Yels, and Kwak Le, who works in my team. Right? These are absolutely incredible inventions because of why. Unfortunately, the animation is not showing up here, but on the left-hand side is showing you that in the past we built separate models for everything. Translation from Chinese to English, English to Japanese, Japanese to Korean, they were all separate models. Summarization is a different model. Now it's all done with one model. What is that? Compositionality. It's automatic compositionality because it's a single model. This was done in 2023, before all the current buzz around coding. Using Gemini at the time, we were able to demonstrate this use case. Can you please fix this code and add line-by-line comments in Korean? And the Gemini model in 2023, 2 years ago, did this perfectly. We checked it with our Korean colleagues at work, and they were surprised. If you had invested in 2023 on, okay, wow. Now, this is the history. This is why we need to look at history, because if you look at history, you can predict the future. What happened was sequence-to-sequence learning, then transformers. In between time, we published a lot of papers about conversational robots. You know, in January 2022, when in the team that I manage in Lambda, we also published at the same time with Danny Zhao and Xingyun's boss. You know, we published this paper on chain of thought. I'm very proud to have been part of the authorship of that paper. But 1 month later, we published one of the most important papers on post-training, which was fine-tuning. Again, if you had known in 2022, before the release of ChatGPT, where to invest, you would be very rich. So I want to help you do a little bit better going forward. I think the way that you should think about the agentic future is the following. Humans are composed of two faculties. This is what Daniel Kahneman talked about. On the one hand, we have system one, which is very fast pattern recognition. And then we have system two, which is very much related to reasoning. Takes slow, methodical, rational thought. Going forward, I encourage you to invest in agentic systems that merge these two capabilities. And if I may ask the AV folks to play a video next to show what this might look like in a project that I manage called Project Astra, and you'll see what I mean by this. Sorry, there I see lots of hands.
I'm here with the latest research prototype of Project Astra, and we're going to see how it can help me fix my bike. Hey, go online and look for a user's manual for a Huffy mountain bike.
I have found a user manual for you. What would you like to know about it?
Okay, cool. Now scroll until you find the section about the brakes.
Sure thing. Looking for that page now.
I think I stripped this screw. Can you go on YouTube and find a video for how to fix that?
Of course. I'm opening YouTube now. This looks like a good video.
Place a rubber band over the head of the screw.
Oh, nice.
Press down
Thanks.
firmly.
Can you go through my emails with the bike shop and find which size hex nut I need?
Sure. According to the email from Bicycle Habitat, you need a 3/8" hex nut for your sprocket. I've highlighted the correct bin for you.
It seems like I need a spare tension screw. Can you call the nearest bike shop and see what they have in stock?
Yep, calling them now. I'll get back to you with what they have in stock.
I think my brake pads are wearing down. Can you check the manual again and see if it talks about them anywhere?
According to the manual, if you look on page
Hey.
24,
Do you want to get lunch?
Yeah, give me 5 minutes. Can you finish what you were saying?
as I was saying, if you look on page 24, section 2, you'll see how to replace the brake pads.
Hey, any updates on that call?
Yep, I just got off with the bike shop. They confirmed they have your tension screw in stock. Would you like me to place a pickup order?
Could you show me some examples of dog baskets I could put on my bike?
Sure, I can help you with that. Just give me a moment. Here are some options. I think Zuka would look really great in these.
All right, if you thought that was a concept video, it's running on my phone. I think I'm probably the only one in the room that has Astron on my phone. You have just seen the future. Now you know how to invest, right? Okay, so what do we need to go to the future? The answer is very simple, actually. If you think about it, if I could have my next slide, please. What you need is multi-step reasoning. You need agentic workflows. You need ability to deal with synthetic data. And you need personalization. That's what's coming, right? So I hope you now will be much smarter about how you invest your personal portfolio. Thank you very much.
Yeah, thanks, Ed, for the great and very fun talk. Our next speaker is Sergey Levin. So Sergey is the co-founder of Physical Intelligence and an associate professor at UC Berkeley. He has been working on developing algorithms for learning those, building autonomous agents to learn those very complex behavior. So in this talk, he will discuss about multi-turn reinforcement learning for building these LLM agents. So yeah. So let's welcome Sergey to give his talk.
Okay, great. All right, so I think Ed gave a great big picture talk. I'm going to give a very small picture talk, but it's also about predicting the future, just in a very different way. So I'm not going to talk about robotics today. I'm going to talk about reinforcement learning for LLMs. There we go. Okay, so an LLM agent obviously interacts with some kind of environment. Typically, this would be some set of tools, some kind of resources that it can use. But we might also want our LLM agents to interact with people or interact with physical systems. Maybe it's actually issuing commands to a smart home or something like that. Some kind of system that's not so easy to simulate. And we want to do a few things. We want to optimize for good outcomes. We want to optimize to get high reward. That's what reinforcement learning is really good for. And of course, we've seen an explosion of research on reinforcement learning for agents. But we also want to handle real-world dynamics, systems that are not just predictable API calls, but unpredictable, messy things like placing that phone call that Ed showed in his talk. So here's a running example that I'm going to use in my presentation. This is kind of a benchmark task. It's from a paper by Wong et al. Called Persuasion for Good. Here, the agent is supposed to be persuading a person to donate to charity. Obviously, it's a benchmark task. It's not something that we necessarily actually want LLM agents to do, but it's an interesting scenario to consider that you can think of implicating many of the phenomena we might expect when, for example, an LLM agent is interacting with a customer, placing a phone call, or trying to interact with a user who's making a very complex request. You have to think about their thought processes. You have to figure out where they're going. Are they skeptical? Are they persuaded? Are they happy? Are they angry? Are they getting frustrated? So this is a very complex kind of domain. And of course, ordinarily, if we were to train LLM agents with reinforcement learning, we would want to heavily use simulation. And that's straightforward to do if you're training agents to make API calls or use tools, but it's not so straightforward when you want to interact with people, interact with physical systems, interact with messy aspects of the real world that are hard to model. So what about, instead of trying to simulate environments so that we can run reinforcement learning for our agents, what if we can somehow leverage the LLM itself? The LLM should be very good at predicting things about the world, especially when it comes to people's behavior, because of how it's trained. LLMs are literally trained to predict which buttons people will press on keyboards. So you would expect that a model trained in this way should be very good at predicting what buttons people will press on keyboards, or what words they'll say, or how they'll behave in the future. So let's try to think about how we can leverage that. Let's go back to our little donation persuasion example. Let's say that our agent observes the person saying this line. Well, inside of that LLM, there are representations, and those representations are actually very good. They're representations of what the model deduces about this interaction. And those representations can be very useful, but they're not by themselves a great basis on which to make decisions, because you don't just need to deduce something about what happened, you need to predict what will happen in the future, not just to make a great investment, as Ed told us, but actually to figure out how to achieve your goal in this dialogue situation. So you need something more. You need to look at these features, introspect them, understand what's going on, and then use them as a basis for predictions. So that other thing that you need, which you'll use to build a really great predictive model of this interaction, is basically domain experience. You need to know a thing or two about persuading people or talking to customers or helping users in order to build a predictive model of this particular situation on the basis of the representations that your LLM has from all that large web scale data. Now, critically, that prior experience does not need to be experience of optimal behavior. So the key thing I'm going to talk about, which is enabled by leveraging reinforcement learning in the right way, is to use in-domain suboptimal experience, which could come, for example, from people talking to other people, which allows you to understand what might happen, and then leverage that knowledge to figure out how to act so that the thing you want to happen actually happens. So the key idea is to analyze suboptimal prior data of human-human interaction to understand how people react to one another, and then using it to build powerful predictive models of behavior on top of these LLM representations. And crucially, we will not be using the prior experience to understand what the agent should do, but rather what might happen, such that we can then plan for the outcomes we want. Okay, so what do we need to predict an optimal strategy? This is the kind of question that we're going to train our model to answer. If I am in this situation, and I take this strategy, what will happen in the future? So you might predict that if you take strategy A, then the outcome is the user distrusts us. If you take strategy B, the outcome is the user is bored. If you take strategy C, the outcome is the user is interested in your charity. Okay, so if you're trying to get them to donate to charity, pick that one, right? That's the good one. So if you can answer these kinds of questions in a very flexible way, that's a really great basis to get your agent to behave more optimally. So how can we formalize this problem? Well, the yellow thing is the outcome. And what you really want to predict is the probability of an outcome given the situation and the strategy. So in the parlance of reinforcement learning, this is the state, this is the action, and this is a goal. And we're going to train these kinds of models to predict the probabilities of many different goals and then leverage them in a decision-making framework. Okay, so this needs to be learned from domain-specific data, and it has to be a long horizon prediction. What will happen if I pursue this strategy for an extended period? What will happen at the end of a long interaction? So this is called the goal condition value function. And actually, classic reinforcement learning gives us really great tools for training these things. I won't throw lots of math at you. This is actually the only equation I have in the slide, and I'll walk you through it. So if you want to learn P of G given SA, it's actually described by a Bellman recurrence, which makes it really convenient to learn from suboptimal data. Basically, that probability is equal to the probability that you've reached the goal already. That's the easy one. But then if you haven't reached it already, then it's the probability that you'll reach it in the future. And that's a recursion. Basically, go to the next time step and see how likely are you to reach it from the next time step if you select the best possible action you can at the next time step. So it's taking into account the counterfactual property that you will be acting to maximize the probability of this outcome. And this is why you do not need optimal data to train these things. The data tells you what might happen, what kind of transition might occur, and then you will ask, well, if I then act optimally, how likely am I to achieve this outcome? So that's why we don't need optimal data, and this is basically just Q-learning rebranded and repackaged in a slightly different way. Okay, and we can, of course, train for many goals at the same time. So how does this work in practice? Well, we take our data set. So we're going to, if we're doing this persuasion task, we're going to take the persuasion for good data set from Wong et al.'s paper, and that has people talking to other people. In every one of these conversations, we'll pull out some time step and treat that as the state. We'll look at what the other person did next. We'll ask our LLM to kind of pretend that you were that person. What strategy are they doing? And it will say, oh, it's executing the strategy. I should explain I want to donate. Okay, that's an action. And then we'll look into the future of that conversation in our data set, and we'll find some outcome. Maybe at the end of this one, the user wants to donate $0.3, so that's the outcome. The goal can also come from other conversations. It doesn't have to be the outcome that was actually achieved in that conversation, but it should be something that's kind of sensible in the context of the task. And using these, we'll construct a data set. The data set just consists of tuples: state, action, next state, and outcome, where the action and the outcome are obtained via summarization, and the state and next state are literally just the prefixes of the conversation at that point. And this data set then we can plug into an offline Q-learning algorithm. We're going to use the representations inside the LLM as the features for this. That's very convenient because the LLM already can take these states and represent them in a way that's fairly sensible. And then on top of that, we can actually train a very small model using this Bellman recurrence to represent these goal condition value functions. So we run offline RL to train goal condition value functions and then leverage the representations as features on top of which to train these things. Now, once we've trained these predictors, we can leverage them in a decision-making loop, which is very similar to self-refinement. So at test time, when the agent is actually talking to a person, we're going to ask it to propose some relevant outcomes that it might care about. So this is just like, make up some things that are important in the context of this task. Maybe it's important to figure out if the user will feel threatened or if the user trusts us more. Like, these are the things we should care about. Propose some initial strategy, maybe a bad one, like argue with the user, and then predict how likely each of these outcomes are using that bank of goal condition value functions we trained. And now you can take that information, you can give it back to the LM and tell it, like, hey, this is what I think will happen if you follow this strategy. Based on this, refine your strategy to be better. And you can perform the self-refinement loop multiple times. So we're not just blindly following the optimal prediction, we're actually plugging this into a kind of a planning process, but now it's a planning process informed by what you've learned from that in-domain data about long horizon prediction. Just to show you at the end how this actually plays out in practice, here's that persuasion task. Here, the donor is clearly skeptical. I think it's a waste of money. The agent has some thoughts. Initially, it says, oh, maybe my initial strategy should be I should talk about the accomplishments of the charity. It evaluates the possible outcomes of that strategy, determines that that's a bad idea, refines it, and then says, oh, I should address their skepticism and share financial accountability reports. And this refinement can be done multiple times. Here's another benchmark task. This is the social deduction game Avalon. For those of you that have played the party game Mafia, it's kind of like that. So there's like a group of players that are playing together, but one of them is like secretly the bad guy, and you have to figure out who it is. So you have to really pay attention to the interactions. And here, too, the agent has some thoughts. It says, oh, I believe the quest will fail because player 2 is the minion, like that's the bad guy. Proposes a bunch of possible outcomes, evaluates their probabilities, and then comes up with a better strategy that could allow them to win the game. So this works quite well in a bunch of benchmark tasks. We actually intentionally chose benchmarks that span the range of different challenges. So web shop is a more traditional kind of tool use AI assistant task, whereas persuasion is much more of like a task that requires understanding human psychology. Avalon requires understanding social dynamics. And across these benchmark tasks, this method actually does quite a bit better, even than methods that are actually designed for these benchmarks in mind. Now, this is kind of a deep dive on a very specific technical idea. The main thought I want to leave you with at the end is that when we build LLM agents, we should really think deeply about how we can use suboptimal data of the kind of interactions that are easy to get to deduce more optimal strategies. And I think reinforcement learning can be a really powerful tool for that. LLMs know a lot about the world, and we can use them to make predictions that aid in decision making. In-domain data can help us, even if it's suboptimal data. Offline RL can help us learn more optimal behaviors, and we can combine all this to train agents using only suboptimal data that could outperform the humans that generated the data in the first place. Thank you very much.
Yeah, thanks, Sergey, for the great talk. Our last speaker will be Jacob Pachowski. He is the chief scientist at OpenAI, and he has been leading a couple of very important efforts there, including the development of GPT-4. So due to the unexpected flight delay, Jacob cannot join us in person, unfortunately. He's still in Europe, I think. But in any case, he will still join us virtually and share his insights on automating discovery, and also he will join our panel discussion virtually afterward. So yeah, let's welcome Jacob to start his talk.
Thank you, Don. Hello, everyone. Very excited to participate. I want to share a bit about where we at OpenAI see AI progress going. The big goal that we are working towards is automating research. automating discovery of new insights and development of new technologies. I believe this is this sort of technological this acceleration of technological progress is going to be the most important consequence of AI progress, and of course it is going to become the core driver of AI progress as well in the future. And there are still some technical challenges in the way. There's still a lot of research on alignment safety that we need to do. And I think there are also some big questions that are a bit less technical about what does it actually mean if we are able to succeed at this, and what is the right way to use and govern such systems. But let's talk about how the technical progress is going. And I would like to highlight two results from the last few weeks that I have found very interesting. Both of them are the performance of our models in competitions. The first one is the AdCoder Heuristics World Finals. So this was a major international programming competition with the best contestants gathering in Tokyo to compete at solving a single very difficult problem over a 10-hour horizon. And we have entered our system into the contest, and we've seen the model was able to beat all but one person. And I thought it was a very cool result. Of course, this is developed by a small team building on top of the more general AI machinery that we're building at OpenAI. And the model was able to find some interesting insights. It was able to optimize its code very, very well. But I think it's also very interesting to look at where the model fell short. And if you look at the one contestant that managed to defeat it, they actually figured out a quite novel approach to the problem that wasn't even in the model's search space. It didn't really look at that. I think this sort of finding this sort of new insight is the thing that we're after, and so I think it's a very it's a very interesting thing to see that that is the thing that was missing there. And a very similar result happened in the International Math Olympiad this year, where our model, similarly to DeepMind's model, was able to solve 5 problems and perfectly and achieve a gold medal level performance, but didn't make any progress on the 6th most difficult problem, which again required a fairly novel insight. And so these are kind of similar results. We have these models that are able to beat most humans, but they are missing this one big insight. And the IMO results, I think, is particularly interesting because this is something that's been a long-standing challenge in the field. I remember a few years ago we were talking about what are the AI milestones that have already been cleared, what are the AI milestones that we see in the future. A few years ago, like the obvious ones, well, there was chess, there was Go, which was a long-standing challenge after chess. There was the ability to interact in natural language. And we're thinking of IMO as this great benchmark of, is the model able to find this fairly general insights? Like, is it able to perform this fairly general reasoning still in this like very well constrained and measurable environment? And one thing that wasn't clear at the time is, should the benchmark be you get a gold medal performance at the IMO, or you are able to solve 6 problems perfectly, including the problem 6, which tends to be a pretty difficult combinatorics problem. And so we're thinking, maybe we should have 2 milestones. And yeah, at the time, I really still didn't expect that we'll have this year where like 2 labs independently say, we have models that like get a gold medal performance. They perfectly solve 5 problems, but cannot touch the 6th one, which happens to be a hard combinatorics problem. So I thought it was very interesting. And I don't think that is accidental, but still, it makes you wonder what is next, right? Because we are reaching this limit, I think, of this like very clean-cut benchmarks, of this like very kind of easily measurable milestones that we are used to for also measuring human performance. And we have to move to these fuzzier, longer horizon tasks where you actually develop insights and you develop things that have real-world impact and actual value. And part of this question, as we go there, is thinking about what is the mode in which the AI interacts with the environment, right? And I think that's very topical for today. Personally, for a long time in the past, I have been reluctant to push OpenAI's research very quickly into extending tool use, interfaces, and so forth. With my thinking being that, while this is like clearly very important, this will ultimately be needed. There is still so much progress that we can make at the time in these more isolated environments, and we need to pursue the kind of core intelligence of the model above other things. And it's not clear whether that was the right path, obviously. And we did have a diversity of approach there. So, for example, Jared Forek, who now leads our RL team, has been relentlessly pursuing this sort of capabilities for a very, very long time. But in any case, I think now we are reaching a sort of point of convergence where the models are smart enough that to even talk about, to measure the progress on their capabilities, we need them to be able to more robustly interact with the world, and to be able to tackle these longer horizon, more fuzzy tasks. And I still want to be clear, right? Like I think that this raw intellectual capability of the model is still going to remain at the core of our focus, and I expect it to continue improving, and maybe more rapidly than before. And maybe a few years ago we were thinking mostly about there's like scaling pre-training. I think now we see there's also progress from reinforcement learning and new insights. But as we continue this axis of progress, it is now very important to connect these models to the real world, to have them pursue meaningful research results. And if you kind of tread that line of thinking and think about what's coming after that, eventually it will become important for these systems to start interacting with the physical world, and robotics will become extremely important. And another thing in this vein that's maybe a bit less obvious because we're already doing so much of it, but obviously people are a huge part of the real world. And of course, systems already interact with people quite a bit. But I think especially for this reasoning, for these agentic AIs of today, there's still quite a lot of room to improve very meaningfully how they interact with us. And I think there will be quite a bit of progress there. A lot of our thinking on safety centers around this this notion that we are building these agentic systems that are going to interact with the world, learning for a long time. And we have to think about how to keep it harmless and beneficial, right? And this starts from these innermost motivations of the system, right? Like, so thinking about value alignment and what is it really trying to accomplish? Going through, can it follow instructions reliably? Going through robustness. I think challenges like prompt injection, for example, are going to be very important and challenging for the field. And all the way to physical and systemic constraints that we impose upon the model. So like, what control do we have upon it without any reliance upon its behavior? And can we monitor how it acts? And there's quite a lot of progress to make on these directions, and we're thinking about this quite a bit. One thing I'd like to end with, that I think is just interesting to think about. I think we have this kind of built-in notion that things that are truly interesting just have to take a lot of effort, right? You cannot pull out just like very novel, interesting things that change your thinking out of thin air. And I think we've already seen AI systems bend this notion a little bit here and there. So for example, when you see AlphaGo discover a brilliant move that people haven't thought about, that feels absolutely magical, right? It just feels like something that, like doesn't really make sense, right? And kind of and just makes you feel a little differently about the world. And, for me personally, it was watching the Dota 2 bot play endlessly entertaining games, like this sort of infinite TV with new strategies coming up. And I think it's just interesting to consider like what this will look like when we're talking about broad real world insights. And if you think about this world where new science just kind of falls out of GPUs, it's a very different, a very weird place to think about. And I think that's worth reflecting on. Thank you for the time, and looking forward to the panel.
Yeah, thanks, Jacob, for the great talk. Now let's welcome all the panelists to the stage. Okay, cool. Like we have heard about a lot of some great talks about different aspects of agents, including this like discussion about this like safety, about personalization, like multi-turn interaction and reasoning. So now let's start for the first question about this like foundation of agents session. So yeah, as Dan has mentioned at the beginning of her talk, there are some sayings that 2025, this year, is the year of agents. But actually, last year, we have also heard those words saying that 2024 is the year of agents. And basically, this kind of voice has been there since these foundation models become popular. But agent word, this word itself is not a new concept. It has been there since decades ago. So for all these panelists, if you think about one or two key capabilities that are only become possible with foundation models, but not really there yet, then what will be the coming up top of your head? So probably we can start with the remote speaker, Jacob.
So the challenges. I think the big challenge that is ahead of agentic systems right now, I think it's pretty clearly the ability to retain memory robustly and continue working for a much longer time, right? Like with models, with systems like ChatGPT, we've kind of become used to this ephemeral AI that you kind of talk to it and then it's gone. And we've been able to extend the duration these systems can productively work for a little bit, and we've been able to have them retain information for a bit longer. But I think there's still an incredible amount of progress to be made there. And I think with what we've seen, with how these models are able to learn in context and explore new ideas there, I think this will go hand in hand with extreme increases in intelligence.
I think on this question particular, the biggest research question that I can think of is what is the limit of a single agent? So what I mean by this is, in my talk, I alluded to the fact that you can compress all these capabilities now into a single model. So, merely 10 years ago, if you had a Chinese to English translation and you had English to Japanese translation, they would all be different models, and the summarization would be a different model. And the QA, question and answering, would be a different model. Now it's all one model. And the question is, how much can we continue to use fine-tuning, chain of thought, RL, to compress further problem-solving strategies into these models such that it can remain one model versus multi-agent? Now, there's a lot of reasons for multi-agent. So for example, once you compress things into a parameter, you can't have access to the most up-to-date information. Like what's the temperature right now, or what's going to be the weather tomorrow, things like that. You wouldn't compress that into the model. So that part of it is obvious. But what about things that people are exploring right now, where we're using multiple agents in order to have parallel trains of thought? Would that remain, or would that disappear? I think that's the biggest question, the biggest missing capability, if you will, that we haven't completely figured out. And in fact, one of the reasons I'm flying red-eye flight to Toronto tonight, precisely because I wanted to be at this conference to hear answers to this question. So I'm paying attention to the talks to try and understand what will be the limit of single agent and where it will be. And then that allows us to, again, predict the future about where multi-agent systems will be.
Okay, yeah, thanks. Thanks, Jacob and Ed, for the great comments. So in my talk, I talked about the challenges in safety and security. I do think that going forward for agents, that is going to be, I would say, the biggest hurdle, one of the biggest hurdles to actually deploy these agents in the real world. I think from actually many different aspects. So one, I just mentioned we want to, essentially make the single model more and more powerful and so on. But on the other hand, we actually don't really have very good understanding. The whole community, we don't really have good understanding how these models work. And we know that these models actually have many problems. They have, even from the security side, from injection, jailbreak, but they have many actually different aspects of safety and security issues for these models. And ultimately, we don't really understand how they work and how to harden the model against these issues. And furthermore, when we put it into this agentic setting, then actually comparing to the traditional systems, this actually becomes even harder. In traditional systems, they are developed, software engineers develop to write these programs. At least there are certain goals, certain expectations of how the systems should work. But now, when we talk about agentic systems, they are so dynamic, we actually we don't even know, we can't even pre-specify how these agents actually what they are supposed to do. The security goals and the specifications of the program behavior is completely out of the window when you have such, flexible and autonomous agents and so on. So this also causes huge problems. Now, when you have these agents running, you don't really know whether the behavior is actually expected or not expected. It's very difficult to actually even try to protect these systems. So I would say, for all these things together, given that we don't have good understanding of how these models work, and they have a lot of safety, security vulnerabilities, and so on, the agentic system is so flexible, so complex. I think the security issues and safety issues will be one of the biggest challenges.
So language models know many things, but it's pretty hard to get them to do what we want. And in practice, any organization that is good at doing this will typically employ lots of people that are very good at figuring out all the details, not necessarily just to make the language model a better language model, but to get it to do things more like what we want it to do. If you work with a person and you ask a person to do something for you, typically if you want them to do it correctly, you would explain what outcome you want rather than the precise steps that they should execute. You might also give them some hints for how to do it, but the most important thing is to get across what it is that you want them to accomplish. And unfortunately, we're not very good right now at telling LLMs what we want them to accomplish. We're much better at telling them how we want them to accomplish it. Now, and that's why it requires so much work. Now, reinforcement learning, of course, does give us part of the answer. And if you're in a domain where you can set it up as a reinforcement learning problem with a good verifier and turn the crank, it's sort of no wonder that those are the domains where so much progress has been seen over the last year. But it's still a very difficult tool to apply because it requires a lot of scaffolding. So to bring this long story to an end, where I'm going with this is that I think what we actually really need to think about carefully is how to be able to train language models directly to accomplish rewards in a way that is scalable, that doesn't require a lot of scaffolding, that doesn't require setting up some manually designed verification or simulation frameworks, where you can define a task, perhaps in natural language, that acts as the goal, train it on data, and this would have to be with offline RL because otherwise you'd have to simulate it, and actually get a model that is trying to accomplish the goal you set out for it with minimal hints about how to do it in advance. So I think that's the kind of technology that we need to develop to make all this very scalable, and I think it's still an open problem.
If I may add something after Sergey's point here that I think is useful, is that when Danny Zhao and I were essentially inventing chain of thought and we were talking about it, the motivation behind it was precisely what Sergey in a way was referring to, was that most machine learning was still dealing with large amounts of data in order to teach the model how to do something. And we really wanted to get to a point where you only have to tell the model once how to do something, the how versus what part notwithstanding, and then the model would learn how to do it, right? That was the motivation behind chain of thought. And I realized recently that this should really become a test for AGI. We have a lot of debate about when AGI will arrive, and nobody knows what the definition of AGI means. And I recently came out what I call the grandma test. The grandma test is the following. At some point in the future, you have a robot in your house, and your grandma will tell that robot, I want the dishes to be put away this way. And I only have to explain it once. And if grandma comes to you and complains, the robot doesn't do what it's supposed to do, you know we have failed AGI.
Yeah, thanks for this very fun discussion. So probably also related to this Ed's point on this chain of thought discovery. So if we think if you think about your past experience on doing this research on agentic AI and foundation models, so what can be one or two key surprising findings, either positive or negative, that you feel that probably it is not unconventional kind of a shared thought among people in this community, and you want to talk about it? Anyone wants to start? Yeah, Jacob, you want to start?
Sure. Yeah, I think it's kind of it's always a surprise, I think, for any sort of AI system we develop. But as we were working on getting reinforcement learning on chain of thought to work, it still surprised me just how many bugs we had to work through, and just how critical that was. And I'm talking software bugs. I'm talking bugs in how we thought about the problem, and in fairly basic parts of the setup. But yeah, even fairly simple things to understand. Yeah, tend to take quite a bit of this debugging in getting deep learning systems to work. Yeah, I think it's just that they are very good at hiding mistakes.
Yeah. Anyone wants to go next?
I wasn't actually super clear on what the question is.
The surprising findings?
Yeah, so in terms of surprising findings recently, or do you think in the future?
Yeah, this question is probably for your past experience.
Okay. Well, then maybe I can offer this a little bit as food for thought, which is I think the most surprising finding over the last couple years is really that computer science originally started as a way to manage the complexity of the problem that we wanted to solve by a very simple principle called divide and conquer, right? So the idea was you have a very complex problem, like safety, for example, and then you would divide up all the different problems, like how do you deal with people who are asking about how to make bombs, and then kids' safety and whatever. And you would divide all these problems into its parts, then you would build modules for all of them, and then you would put it all together in a system-like way. And part of the reason why we're here in this form is because there's a set of people, a huge amount of you, I imagine, are trained as computer scientists. And the moment it's multi-agent system, it's modularized or whatever, you get very excited because all the training that you have been, you've been sort of receiving over decades, now all of a sudden reapply, basically, in this world, right? But I think the real surprise over the last, I would say since 2017 or so, because the transformer paper and the sequence-to-sequence learning paper I mentioned before, is that there has actually been a great convergence, right? The convergence of functionality or capabilities into a single model. And as I mentioned, because we don't know the limit of what that looks like, the big surprise is that we then we keep getting surprised by the compositionality of the model. And that is an incredibly powerful concept, and it's creating such big revolutions in our field because even computer science education has now got to all of a sudden change, right? How much, I have professors coming up to me asking, how much of traditional computer science should we even teach? Should we only teach them AI? Are we now a department of large models? Or is it really computer science, right? So I think the big surprise that I hope, if somebody in the audience, I don't know if there's audience questions, but if someone asks me why I keep saying 6 years, but if 6 years from now we're sitting here together, I hope we have figured out that question. Because I think, if I'm not mistaken, many of you feel a great sense of anxiety. And the reason why you feel a great sense of anxiety is because anxiety arises from uncertainty about the future. If you don't know the future, you will feel anxious. And I feel the same anxiety because I don't know how far this is going to go. And so compositionality and how far it goes is by far the biggest surprise I think we need to address as a field.
Yeah, thanks. Any more comments here?
Yeah, so I don't know if this is necessarily like all that surprising to those of you that work on these things, but I think that there is actually something pretty interesting in how language models can simultaneously be really good at combinatorial generalization, also really bad at it. In that, like, I think it's really remarkable that you could fine-tune a model to become better at some set of tasks, and that will also make it better at other tasks that are kind of structurally related. That's really cool. That's kind of the sort of thing you might expect from a person. If they practice some things, they also get better at other related things. But then it's also very easy to get into these situations where, like, you just realize just how bad the analogy that, oh, this is like a person really is. Like, you can change a prompt a little bit and get a great solution to a problem that otherwise you'd have gotten a terrible solution to. And I think it's very important to remember that a language model fundamentally works very, very differently from a person. That maybe it's more accurate to think about it as a very large group of people, and when you provide a prompt, you kind of index into recalling a generation from something from the training set. But what that implies is that maybe we shouldn't think of agent training processes like the RL stuff necessarily as teaching them all something new, so much as convincing it to do the thing that we want. And taking that perspective, I think, might be kind of healthy in thinking about the right space of methods in the future.
Yes, so I would say that I think the entire journey has been full of surprises. I think, so my group actually started working deep learning, very early, actually earlier than most people in the field. And also actually with Xingyun, like we started working, we were among the others to work on using deep learning for program synthesis, code generation, and so on. Even back then, like I was telling Xingyun and others, like every day, like you can call it pleasantly surprised. Like we did, like for the task that we didn't think that actually just training these neural networks could solve, it could solve it. And then the next day, the next week and next month, we give it a little bit harder task, and then we were pleasantly surprised again. It could actually, just by tuning in, they can solve it. And then at one point, I was thinking, really, how far can we go? For sure, we are missing some critical ingredients to actually help us to get to AGI. So this is like, way before ChatGPT and GPT-4 came out and so on. But I think one surprise is that I continue to be pleasantly surprised. Maybe at some point I should stop being surprised just how this how this path has given us like so much win. That these models can really be trained and learned to do all these crazy, amazing things. But of course, on the other hand, they also really make very stupid mistakes, and also they can be easily attacked. So that's why I think this journey has been full of surprises, and I think continuing going forward, yes, hopefully will be pleasant surprise, but also hopefully some of these issues can be addressed as well.
Yeah, great. So let's first probably have a final question. So yeah, it's related to this like scaling paradigm. In the past, we have seen these like different ways of data scaling, like compute scaling with like scaling up model size and also reinforcement learning. So what do we think that scaling is just the way to go? And if not, or if yes, so what's the next scaling paradigm we should envision?
I think we're running short on time, so I'll keep my answer brief. But I think a lot of the discussions around scaling that really kind of happened over the last 5 years or so, and particularly in 2023 inside of Google, almost all the conversations were about scaling pre-trained models. And I think it really missed the point for quite a while because we were already in 2023, the Lambda team was mostly working only on scaling and figuring out post-training. And even then, at this point, I feel like people are missing the point. I think there's another scaling that's happening that no one is paying attention to. And that is every generation since pretty much 2021, 22 or so, the medium-sized models become just as powerful as the previous version of the large models. So every generation moving forward, the medium model is getting benefits from training the large models, and we essentially distilling that into the medium-sized models. That very much suggests that there's another scaling law that's happening at a smaller size level. And perhaps as another answer to the surprise question would be, how far can we go with that? You know, will we get to a point where you know, a medium or small size model that eventually that would run on your phone would be only 2, 3, or 4 generations behind the largest models, but still much, much more powerful than the current large models that we're already putting into production right now. If that's the case, by the way, edge inference will become more important, and your investment portfolio should change.
Yeah, more thoughts from the speakers?
I think that well, I really appreciate Ed's answer, and I also think that what scalable means in the future will probably be a bit different. My take on this is that I think one of the most important things that should be made more scalable is, as I said before, defining what task you want the model to do in a way that it actually listens to you. And I think that that's a different kind of scale. It's not about scaling so that you can use more data. It's about scaling so that you can add more tasks and more capabilities in a way that is efficient with respect to the human labor that goes into it. And I think this is a place for new methodology to make big improvements.
I think we are, you know, taking this current scaling paradigm largely actually because we don't know how to have better, more data efficient algorithms and approaches. So I think going forward, I really view the next frontier is how we can actually develop more data efficient algorithms and approaches. So that is actually the right way to scale.
Jacob?
I think we have a very long way to go on scaling this thing we call test time compute. I think even the name test time compute is kind of, you know, it implies a fairly low scale. Really what we're after is scaling learning in context, right? Because that's what we see these reasoning models doing, exploring new ideas and finding new insights. And, you know, right now, the sort of compute that we spend on that, even for this, you know, like IMO contests, like I think it's nowhere near where it can be if you compare it to what we spend on training systems in general.
Yeah, great. We have run out of time. So yeah, thanks a lot for all the panelists. We have a fun discussion. Yeah.
Thank you.
All right, my name is Sharon Goldman. I'm a journalist. I cover AI for Fortune, and I am pleased to be introducing the focus talks for the next session for next generation enterprise agents. So we're turning to real-world adoption of Agentic AI. And we're starting with Burak. Is Burak here? Burak Gökturk is VP of ML Systems and Cloud AI Research at Google. And he is going to get us started with our first focus talk. So welcome.
Hello, everyone. We just set up the slides, so hopefully it works. OK, perfect. I see it here. Hello, I'm Burak Gökturk. I lead research within Google Cloud, and at the moment we're focusing a lot on clearly AI, machine learning, and also systems and how we combine them together as well. Today, I think I have about 8 minutes or so. I'll focus a little bit about some of the trends that we're seeing when it comes to AI, and then also tie them into how we're building multi-agent systems and how you can use some of those trends as you design things as well. Perfect. First of all, just a little bit of quick briefing. I think you've all seen that things are moving super fast when it comes to AI and machine learning. Now, if you back up for a second and look at what is happening, actually lots of the algorithms that are working on are from last century. It's all about neural networks, right? And it's a set of weights, a set of hidden nodes, and given some inputs, it's trying to predict the outputs. And again, the main optimization is coming from last century too, backpropagation. Indeed, most of us, like when we were looking at in early 2000s or earlier, neural networks wasn't the best performing AI algorithm. What happened? And we were all thinking even, OK, why is it even in textbooks? It was that bad in terms of performance. We missed a couple of points. First of all, neural networks, both in terms of prediction of the nodes, so separation of how we can parallelize the model weight predictions, as well as data parallelism, it gives you lots of leverage to be able to distribute into many machines. So you could do many of the processing in a parallel manner, especially when you're doing the training. Now, parallelism is only useful if you have lots of data. And so we needed to figure out how to create lots of data as well. And then I think you've seen all of this. People have come up with the concept of masking, which is essentially having lots of sentences, images, etc., and then masking parts of those sentences. For instance, in a sentence like Istanbul is the biggest city in Turkey, you can mask some of the words and then use those words as part of your training set. And all of a sudden, if you use all of the web, you have trillions of pieces of training data and means for an algorithm and a training algorithm for means to be able to parallelize it. So all of a sudden, neural networks literally moved from being one of the not best ones, I shouldn't call it worse, but not being one of the best ones, to clearly the best one in terms of AI predictions. Now, of course, you've seen various papers like attention is all you need. The transformer structures came, again, building on more or less lots of the neural networks as well as backpropagation as well. So we landed where we are. And now let me mention a few of the trends that we are seeing. And we've gotten this through talking to lots and lots of enterprises. And I'll go one by one on these trends. And then maybe give a little bit of a few hints on how you can use as you build your agents and agentic systems as well. So first, maybe about 2 years ago, it was the choice of the model. But that's changing. It's now choice of the platform. Why? This is one of the leaderboards. There are many leaderboards that evaluate how large language models are doing across different artifacts. And if you look at LIMS's chat leaderboard, it's changing literally every other week. And every few weeks, another company is coming up with a large language model that is performing really well. So that clearly says that you need to really focus on the platform also, not just the models. You need to be able to have an access to a broader set of models. And as you build your agents, one thing that you're going to be seeing again and again, you need to adapt these models into your own use cases. And more specifically, that means fine-tuning as well as distillation. And of course, you need a platform with toolsets for agents in production as well. So this is Vertex AI, Google Cloud's AI platform. But in any good platforms, you should see some layers like this. Again, what we call a model garden, a place where you have access to lots of different models. A model builder where you can customize those models through fine-tuning and distillation. And an agent builder with all kind of tool set to be able to move from just models into agents. This is anywhere from orchestration to extensions to connectors, document processing, etc. And okay. Let me just go fast. The second trend is really search. One thing that we are seeing from many, many enterprises is that you need to combine large language models with search to build successful agents. The reasons are clear. Large language models are trained in the past, so they will not know the score of the game from last night. They hallucinate, and it's a feature, right? They need to be creative. So sometimes they're not exactly right in terms of factuality. And finally, they cannot cite, and it is very important for many applications to be able to tell where the data is coming from. So with this in mind, maybe one lesson I want you to take home is that you will need to go to search in many of your applications. Now, let me go to the next one, and it's clearly the time for agents. And LLMs cannot do everything, right? So you need to be able to combine it with different tool sets. You need to be able to maybe make multiple LLM calls in your agent. And if you look at the applications that we have seen early days, it was conversations, summarizations. LLMs can do by itself. Now the time has changed. The way I define agents is that anything that agents cannot do just by themselves. So what it means is it needs to use different tools. It needs to do function calling and be able to combine all of that. And again, going to a good platform with a great tool set is going to be very key as you build your applications. These are some of the key attributes. I think function calling is the one that I would like to call out here, as well as probably memory usage as well for personalization. But and function calling is still a challenging task for many of the large language models, because A, they need to figure out that they need to call a function to be able to answer a question, and B, they need to be able to call the right function. It's a challenge if you look at leaderboards. If you give 100 functions or so to choose from, the accuracy rate of choosing the right function is in the order of 50, 60, 70%. So this is one thing to remember. If you're building agents, try to start simple. Do not try to set up an application where you're calling, like, you're trying to choose from 100 different functions. Now, let me jump to the next trend, because I have about 1 or 2 minutes. You're going to see single agents as well as multi-agents as well. I would like to give one example of a multi-agent. This is a paper that we recently published. It's called Co-Scientist. And it's essentially a medical discovery system, where think of you're a medical researcher doctor, and you have a research assistant, and you're telling them to go and make a research. It would go read all the papers. It would read all the papers in both the illnesses researching as well as adjacent illnesses. It would do a full review. It would self-evaluate itself. It would do the ethics check, etc. All of these are essentially parts of a multi-agent system, and each one of them is a different agent. So I'd like to jump into some of the results of this. Of course, you can do this many, many times as well, because it's essentially computing time. And we've seen really great results with this in discovering different hypotheses for especially unsolved illnesses. And I'm giving just a medicine example, but indeed you can apply it in many different fields. Let's actually play this video if possible.
With the answer in 2 days that it had taken you around 10 years to find. what was your reaction?
My reaction, I was shopping with somebody. It was a Saturday afternoon. I was shopping with somebody, and I said, please leave me alone for 1 hour. I need to digest this thing.
Wow. Okay.
So, and then the first thing I said is, I wrote an email to Google, say, you have access to my computer, is that right? Because otherwise
you thought they were cheating.
Yeah, absolutely, because and also, sometimes I use ChatGPT or whatever for improving my English. Also, you have access to this chat. He said, no way. He said, this is all based. It's not just that the top hypothesis they provide was the right one. Okay, it's that they provide another 4, and all of them made sense. And even for one of them, we never thought about it, and we are now working on that.
So this is Dr. Jose Panades. They've been working on a secret kind of approach to figure out various illnesses for 15 years. Then the system was able to come up with the similar output in literally 1 day, and more so as well. And then maybe another one. This is an expert in the genetics field. He has, I think, more than 1 million followers on X, by the way. And we demoed it to him. He actually cured some illnesses as well, again, using genetics, but it took him like 20 years. And what he said was, after what I've seen today related to an AI model, I can confidently claim that the scientific process will never be the same again, and that he's 99% certain that all diseases, including cancer, will be cured within roughly 10 years. So these are some of the feedback that we're getting. Again, this is one example from medicine, but what it's telling us that it's really making us go beyond what we thought was imaginable. These systems are able to do what a human would do probably in 100th lifetime of her or his. And we're going to see results like this in all of all of the approaches and all of the multi-agent systems that we're going to be building. So let's be ready for that. And as a closing thought, the last thing is that we're doing lots of work in combining AI and systems, and this is going to be super important as well. Maybe comes as a second thought, but systems are a huge bottleneck right now. They're improving with the Moore's law, which we thought was exponential, but it's actually sublinear compared to how fast AI is going. So you will see AI and systems coming together more or less in everywhere. That's because the systems will need to catch up to be able to really deal with all the demand that we are seeing when it comes to AI. So these are some initial thoughts. We can answer more questions in the panel as well. Thank you all for your time.
Okay, thank you so much. Our next focus talk is Arvind Jain from Glean, founder and CEO.
Thank you so much. Hello, everyone. My name is Arvind. I'm the founder and CEO of Glean. Glean is an enterprise AI company. You can think of us as ChatGPT, but inside your enterprise. Glean, Glean connects with all of your company's data and knowledge and information, and then it helps people with any questions that they have when they're doing their work, and we bring all of that institutional knowledge and memory to help them with their tasks. Today, I'm going to talk about the role of AI in the enterprise and what are some of the key challenges that businesses run into when they try to deploy all these amazing AI technologies, that we just saw from Burak, in their companies. So number one, every enterprise today is thinking about how they're going to transform their business with AI. They want to automate a lot of business processes. They want to bring efficiencies. But the first challenge that they run into is that they don't actually have people who understand AI. And when you think about driving AI transformation, we believe it's really a two-step process. First, you have to figure out how you're going to actually transform your people. How do you make them comfortable with AI? How do you make sure that they're not afraid of AI? They're not afraid that AI is going to take their jobs, and make AI a part of their day-to-day work. And when you do that, when you bring AI to people, when you show them the power of AI and see how it can make them go 10 times faster, that's when you sort of start to get that motivation. That's when you break the inertia, and that's when people start to learn how to actually make AI part of their day-to-day work. Once they've done that, then you're ready as an enterprise to transform your business. These same people who become experts on AI now can go and take every business process that you spend as a business a lot of money and resources on, and you can go and figure out how you're going to actually bring AI into those processes to bring efficiencies. The second thing, when you think about AI in the business, a lot of focus tends to be on cost savings. The first, like when you talk to most executives in a business, the first thing on their mind is, how do I use AI to save some cost in different departments? How can I actually have fewer people? How can I improve my bottom line, increase profitability? And there are a lot of opportunities for that. Today, when you think about your different business processes across different teams, whether you are in R&D and writing, your developers are writing code, or you're in sales and you're selling products, support where you're helping customers resolve issues with your product. Every one of those departments, AI has a big role to play in those and bring significant efficiencies and improve your bottom line. But the focus on bottom line often takes away from the main thing that AI can do. It's the thing that we just saw from Barak, the AI co-scientist. There is something that humans just couldn't do before. There are new things that AI makes possible for us, and that's the thing that enterprises are trailing today. They've not actually figured out what new products they can build with AI, how they can fundamentally make people achieve things that they couldn't do before without this technology. There are a lot of examples now of how you can actually improve your business's top line with AI. But how do you bring all of this AI innovation inside your enterprise? Today, when you think about the industry, there are lots of AI startups, a lot of products that you see from both new and existing software companies in different domains. You can pick any particular department or vertical. For example, take your HR, human resources teams, take your legal teams, finance teams. For every persona, for every vertical, there are hundreds of different AI tools that are available for you to pick and bring into your enterprise. And that actually creates a big problem for enterprises. It's very, very hard to pick what works, what doesn't. All AI demos look really exciting, really powerful, but you don't actually have people who know how to actually tap into it and leverage it. And that's one of the key challenges that we hear from when we talk to our customers is, like, how do I handle this? How do I actually pick from one of these thousands of different tools? And also, how do I actually bring AI in a way that is safe and secure and compliant with our policies and regulatory requirements? Security is actually a really, really big thing, because all of these AI products or technologies that you're going to bring in, they're going to need to work on your enterprise data. They're going to take it out from your systems and make use of it in your AI systems. And so these are some of the key challenges. And for us, at Glean, that's one of the problems that we solve as an horizontal AI platform that's connected with all of your enterprise systems. You bring Glean as one AI product. You connect it with all of your enterprise applications and systems, and then you deliver the right data to the AI models through this one single platform where you can implement all of your security, governance, and privacy controls. And last thing that I would say is, where are we headed with AI in the enterprise? Today, AI is a very reactive tool that is actually, of course, getting a lot of use. A lot of us now use tools like ChatGPT. But it's always new. We have to go to AI when we need something. AI is actually very reactive at the moment. The future, though, in the business is different. We believe that AI is going to become a lot more proactive and will completely change how work happens in the future. The vision that we have for us is imagine a personal companion that you have, who's with you at all times, when you're working. It listens to every word that you speak. It listens to every word that you hear. It goes and attends meetings with you. It's right there with you when you're having water cooler conversations. It reads everything that you write. It goes and sees what activity do you perform in every different system, inside your work. And with all of that understanding and knowing who you are and what your goals are, what you need to accomplish in the next 3 months, what you need to do today, it now actually helps you proactively. Every morning when you wake up, you see that you had to do 20 tasks today. And out of those, it already has done 10 of them for you because it sort of had all of that context about you and how you do those things. So that's where we're headed, and that's what we are actually, excited about building at Glean. So with that, I'll stop. Thank you so much for giving me the time, and I'll be, here for more discussion with the panel.
Thank you, Arvind. Next up, we have May Habib, co-founder and CEO of Writer. Hi, May.
Hi, everybody. Sharon is my online friend. I think this is the first time we met in person. All right, clicker, here we go. Okay, so folks, I am May Habib, co-founder of Writer. We are almost 5 years old, and we started in 2020 to productize on top of Transformers, which we have been building in-house with our in-house research lab since 2020, which means it has been the Eras Tour of generative AI with a product that looks very different today. And not surprising, given the kinds of talks today and what general purpose LLMs can do now. We are deep in making Agentic AI work inside of the enterprise. And before the panel, I'd love to share some frameworks that have really helped us bring Agentic AI to the enterprise in ways that have scaled. The first is this rubric right here. Not every job in the enterprise requires nor needs, nor is allowed a fully autonomous agentic system. And we have indeed seen a range of outcomes that are really impactful, building along a spectrum of structured workflow from very unstructured productivity and ideation sessions all the way to very structured work. And then a level of autonomy from lower autonomy to much higher autonomy as we guardrail a general purpose model here more or less aggressively given what a user is trying to do. And when you apply that with a definition for Agentic, for the enterprise, suddenly folks have got a framing for what they can do. And we work with everybody from a Uber that obviously knows its way around AI to a Vanguard and a Franklin Templeton, literally 150-year-old organizations where folks are like, what do you mean by an agent? And everybody is pitching them Agentic, and they really do need a way to think about the autonomy and delegation of what these agentic systems can do. So this is our framing, level 1 to level 4, and it really helps people frame their thinking. From a UX perspective, we've had to create, I think there's a video here. Let's see if I play it, clicking next. Not sure. Oh. Thanks, folks. We've had to create different UX paradigms for the enterprise to think about approaching Agentic from a more structured, less autonomous way to a much more autonomous, much less structured way. And those two UX paradigms have really helped. They are both natural language driven. So the workflow that was up there for a second that felt more left to right versus a workbench like what you see here, those are both very natural language driven, but in the one that is workflow based, you are able to specify, these are the ERP systems that I need you to use, versus the model really deciding in a specific context. So what we have seen with just incredible speed here is the amount of productivity that folks are achieving. And we have seen it in situations where the enterprise has set up a greenfield opportunity and really tried to build around a agentic capability versus staffing up or doing things the old way, where folks have been able to run a whole division or a whole project with 10% of the headcount that they would have done only a few years ago. And that is really, really incredible. That is the future that I think we are getting to. It is going to be very much in a few years, enterprise work being about managing AI that does the work versus truly being the ones that do work very manually. And in a world where that is the case, as we have heard from other speakers, supervision really becomes quite paramount. And this is where we spend a lot of our research time. This is where we spend a lot of our product energy right now. And what we have seen is really, from a security perspective, yes, you need end-to-end decryption and audit trails and isolated cloud infrastructure. That is table stakes. Agents introduce a set of new challenges because they're not following fixed logic. And it means that you are really trying to contain behavior versus securing a workflow. And that new agentic primitive that we've developed is around the sandbox environment. And the reality is, for a lot of these tools and systems that we interact with in a real-world environment, the enterprise doesn't have a sandbox environment. You might have it for Salesforce, you might have it for SAP, but no other systems truly have a sandbox environment with data that mimics the real-world data the agent is going to be interacting with. It means we are synthesizing it. And that is a very, very exciting way to think about how you secure agents. The second primitive in that transparency bucket is around reasoning traceability. Because dashboards are dead. You cannot build and dashboard your way to transparency around these agentic decision-making processes. But you do need real-world visibility into the operations, the reasoning of these agents, and to the alignment with the guardrails and to the goals. And that's really how we have to evaluate the agentic performance. And lastly, and most importantly, control. In the past, control meant setting permissions for users per a particular system. But you don't really permit a human, right? And you don't permit a coworker. You delegate authority with clear boundaries, and we need that to transfer over to agentic systems. And this primitive of control that we've developed here is about designing safe delegation paths for agents. And we have developed and all need to further work on the governance frameworks that define an agent's scope of authority, and then, of course, the ability to constrain that and make sure that's what actually happened. So this is what we think defines the new enterprise. The organization becomes much more this dynamic living network of people and agents and systems, all connected by delegation logic, by execution loops, by escalation paths, by goals set for the organization that apply equally to agents and humans. Who delegates to whom? What agent is best for what job? We are very soon going to have AI that hires humans, right? You wrap an MCP server around an API that hires experts, and we have a much more complex organization than the org charts that we've got today. Thank you.
Thank you, May. Okay, our last focus talk, we've got Richard Socher, founder and CEO of U.com.
Hello, hello. All right, very excited to be here. Always nice to visit Berkeley, even though I did my PhD and was a professor at Stanford. But you know, at that graduate level, there's just lots of love in the research world. I want to talk to you today about search APIs for accurate answers and agents. But before we dive into the details of how we can actually make these kinds of agents accurate, I want to maybe zoom out for a little bit and talk about what I would call anthropic bounds, which are pretty much everywhere in AI. And what do I mean by this? A lot of the AI training data sets, the evaluations, the benchmarks, even the tasks that we give AI are all human defined, right? So you look at all these different things like image classification, as one of the authors of the ImageNet paper too. You look at reasoning and Stanford, like question answering, and superclude, like language understanding. Those are all tasks and data sets defined by humans. So when we think about sort of where AI can go long term over the next few years, well, if that's how we evaluate it, then obviously the most you can get to is just slightly above an average human annotator, right? Which isn't as exciting. It'll be very hard for us to get to something like superintelligence that is even beyond not just a single human, but like super humanity intelligence. And even some of the amazing things like Chatbot Arena that are certainly another better level up there, we are still defining these ELO scores based on human preferences, right? And again, it's going to be very hard to create superhuman intelligence. Now, what would be a path to be better than humans on a lot of different things? I think that is through simulations, and anything you can simulate and or verify, you can actually get to superhuman capabilities. And in a very concrete way at U.com, where we're seeing is that search and especially browsers are going to be one of those ways that agents can actually access a simulation. In some ways, you can think of the browser as a projection from the real world into actionable online activities. And maybe even now going one level below, we can think of almost all the technologies that we've built, mobile phones, computers, GPUs, browsers, search engines. All of those things are going to be ultimately infrastructure layers for superintelligence and various AGI and standard AI before that. And so what that means is we got to make sure those infrastructure layers, sometimes you just have to have a certain number of flops with the GPUs, but you also want them to be very accurate. And so now we get into sort of that last mile problem for agents. This was a paper published by some folks from Penn State and Salesforce Research evaluating answer engines. And what a lot of folks find is that while we have ML systems and AI systems that are very accurate sort of in a one-step kind of shot, that if you have a flow, and agents usually have to take multiple actions, right? If each of those steps is 95% accurate, well, if you're 95 to the power of 30, they'll be only accurate like 1/5 of the time for the entire workflow. And that is something that we're seeing. And here you can kind of see an evaluation of these first iterations of answer engines in 2024 still, where they compared U.com and a few others. And you can see that almost none of us were perfect, right? Though U.com was the best and most accurate across all of these. But there's still too many uncited sources, unsupported statements, one-sided answers, and things like that. Only a few, like U.com, were able to at least not give overconfident answers when we shouldn't really be confident. And this is something that was kind of okay for consumer adoption, but now that we're looking into enterprise, and ultimately I think almost all of these companies will converge into what is, I think, the killer app, no pun intended, of LLMs, and that is enterprise productivity. A lot of times, consumer search, people ask actually very simple kinds of questions to a normal search engine, like what's the score of the game, what's the weather tomorrow, what's the price of the stock? And there's not much you can do to be 10x better on the majority of such simple questions. But for the really complex things, that's where we actually can do much, much better with these more complex LLM-based systems, and that those complex questions are in enterprise productivity. So now, what do you do to actually make those agents more accurate? You have to give them, as a step one, a very, very accurate search backend. And it turns out that is a hard enough problem that we've now been working on for years, but it's starting to pay off. And it's actually now our biggest line of business is actually enabling all the other LLMs to be up to date, to have real-time citations about things that are happening in the world, and not just have accurate content, but also accurate citations. And so you might ask, is it still actually possible for a smaller company like U.com, not tiny, but also not nearly as big as OpenAI, to beat some of these larger folks? And I think a similar question you might ask if you're a Berkeley PhD student or you work in other small companies. And the interesting thing is that the answer is yes. You just have to focus on a particular kind of use case. So in this case, we've had deep research agents. We used to call them just modes, like research modes, but then realized at some point everyone is calling these things agents because they are taking actions, but the actions that they take are not necessarily clicking in a browser. And that's where we differentiate between knowledge and action agents, right? Knowledge agents, they have a few actions like knowing when to search and searching more deeply, and programming. And it turns out, software ate the world, so programming obviously is a very, very powerful action. And so what we did here is we focused on just very exhaustive, long, carefully put together research reports, like 30 pages with 500 different sources and things like that. And then we actually asked the OpenAI O3 model to be the judge of which of the research reports are better, those of ARI, our advanced research and insights modes of U.com, or that of OpenAI's deep research mode. And according to the OpenAI model, the ARI report does beat the OpenAI outputs of deep research. And so initially, I was somewhat surprised, actually, that we're that good. And of course, we don't want to rely on just a data set that we published. So we also ran this on the Frames benchmark, a benchmark created by Harvard, Meta, and DeepMind, that basically evaluates fact retrieval and reasoning across multiple constraints, and then trying to accurately synthesize multiple different steps. And so even on that benchmark, which you can run yourself, we can actually and have beaten GPT-4o models with search and various other open source models and other smaller startups. And so what that means is you can really do better if you focus and you just spend a lot more energy and cycles and also compute and tokens on a particular kind of task. You go deeper in terms of, in our case, numbers of citations, unique web pages, unique domains, to then be more likely to give you accurate research reports. And so one thing that is, I think, super important and I think overlooked a lot, especially in enterprise applications, is when people say, oh, we're the most accurate and so on. It's just kind of marketing, blah, blah. But as a former professor, I feel like I couldn't stand up here and tell you, like, we're the actually most accurate if we didn't have an open source benchmark. And so you can actually go on GitHub and download and rerun and evaluate and test and compare any other deep research model and know that all the numbers actually check out. And so, yeah, we're seeing, similar to the previous speakers, a lot of folks incorporating these kinds of new workflows and getting massive speed-up increases in journalistic processes, but also in healthcare and insurance companies and hedge funds and so on. And so I won't go into too many details, but we can basically think about all the different consumer and enterprise software applications that have been built over the last few years. And in almost all cases, they can become a new infrastructure layer for these agents that are now coming out. Everyone can benefit from having an LLM, for instance, access live news, because no one can train an LLM yet. Every 5-10 minutes, something happens in the world. And so really would love to work with more of you, both as customers, but if you want to build these kinds of systems, also love for you to join us. Thank you. Sit down now. Yeah.
Okay, thank you, Richard. Okay, we're going to start. We're going to have our panel. So if we could have the panelists come on up. Awesome. Our time is a little tightened, I'm told, so we're going to get a good conversation going quickly. Is this on? Yes, okay. So in my world, covering AI as a journalist, I find myself having to wade through a ton of hype. Richard called it marketing blah blah. And it's hard. It's really hard for me to tell what is hype, what is real. So maybe we could just start by each of you giving us a sense of where we really are as far as that balancing act between both the capabilities of Agentic AI and also the organization, a Fortune 500 company, Fortune 1000, Fortune 5000. Where are they at in being able to implement that? Maybe we'll just start with May.
Yeah, happy to start. It is incredible. You can go from an idea to a working prototype in 90 seconds now. No Figma, no PMs, no engineers, no designers, and a lot of people are very excited about that capability. But the reality of what is actually scaled and in production beyond generic chatbots in the enterprise is very, very different. Maybe we do this as a lightning one, but that's my take.
Yeah, I think it is incredibly hard to navigate AI right now because there is actually a lot of unfounded hype, but there's also a concrete reality. These models are getting incredibly smart. There will never be an AI winter again, and if there is, it'll be like a California type winter, you know? And so I think we are seeing similar things where a lot of folks want to do the latest and greatest vibe coding. You can get a prototype really quickly, but that doesn't mean a company can really rely on that. And then you go into like, okay, how do we make this real? And then you realize there are a lot of just data problems, permission problems, and so on that companies have just to get access to all the different data sets, and then maybe get to knowledge agents being there and actually working. I think the action agents for larger enterprises will probably take another few years to really get major adoption.
Similar takes. But I think I would say that it's, it varies from enterprise to enterprise. Some of them are more eager than others. Some of them are willing to forego governance and oversight more than others. And that's sort of, I think, what makes the difference. Like the more you're ready to experiment, the more you sort of see progress with agents. Agents are there. Like, I would say that at most of the large, like if you take the global 2000 or Fortune 500, I would say that every one of them have at least built a few that are actually adding some business value to them. But there's nowhere close to like thinking about like, well, 50% of my enterprise work is now happening with AI. That's like very far from that.
Yeah, I think very similar to us, especially with agents and multi-agentic systems, we are seeing things that's almost unimaginable. And we've seen some of it with co-scientists. And when I say unimaginable, actually, it's not about just super intelligence. It's being able to do things that a human would take maybe 100 years. And do it in one day or less. So this really brings lots of new opportunities, especially in the researching areas, and all enterprises have many research areas in their tasks. So we will see lots of progress there.
So what are the biggest technical bottlenecks? We've brought them up, a lot of folks have brought them up here, everything from hallucinations to issues with reasoning. What are you hearing from your clients and potential clients that they're just still not trusting the systems? Arvind, maybe start?
Yeah. So I think there are the problems of AI, and then there are the problems of the enterprise. So there's a lot of challenge just in terms of, well, as a company, do I even have the right data? Have I actually curated it? Do I have a lot of stale information sitting out there which is no longer correct? So I think companies are also actually struggling with just that part of it. Like, do I have the right information? Is it actually just in people's mind? Is it documented so that I can actually present it to AI? So that's one challenge. Second is, again, like outside of the AI models, is this issue of, well, I mean, there's a lot of information inside the business, and a given agent, it needs to have some information like to perform a given task that it has at hand. And how do you actually bring precisely that information to it? And this is where Richard was talking about, like, search plays a key role in bringing the right information to the agent so they can do their work. And there's a lot of loss, at that step also. So I'll just focus on those, like, since, oftentimes AI gets the blame. I may not use this one. Oftentimes, AI gets the blame, but there's a lot of like stuff outside of AI which is also coming in the way of, agents becoming successful.
Yeah, I can add some as well. Can you hear me? Okay, perfect. I mentioned function calling in my talk as well. Currently, many of the large language, actually all of the large language models are not super great, especially if you provide lots of functions to call as an option when choosing the right function for their task. So this is something definitely to watch. Another thing that I would mention is personalization, or really retrieving the right information from memory or memory banks. And I think this is where, again, combining search and retrieval engines with large language large language models becomes important. And there's lots of context in the past. How do you retrieve and use the most relevant information and be able to provide personalization? I think those are some of the, there are many more, but I think those are some of the ones that comes to mind.
Yeah, maybe every company needs to look at the kinds of workflows that are very core to what they do as a company, and where can they rely on outside services that do this kind of thing. So most companies have marketing and sales and service teams, but it's not the core for that company, so they can rely on agents from other companies. But each company should also decide, like if you're an insurance company, you probably really want to look at risk and classifying and identifying risk very, very well. And you should probably have some core expertise internally. And then for especially the things that are internal, but even for working with other partners, you want to ideally build virtuous data cycles, is what I call them, where just by doing the workflow manually, you're actually collecting clean training data for an AI to be able to take over. So let's say in service, emails come in, just some random person in the Gmail account like answers that email. Well, it's going to be hard for an AI to then take that and automate that workflow. But if you have a CRM, you have concretely like that email comes in, it gets assigned somewhere, and you store somewhere how that email got actually resolved, then you can use that data eventually and have agents take over those workflows.
Maybe one last thing, Nad, that hasn't been said is, for so many enterprises, the kind of work that Agentic AI is going to be amazing at taking off people's plates and scaling, the workflows aren't written down. And so simply collecting that data we see as a big bottleneck, because it's nobody's job today to do that. Somebody has to be told, put everything else aside and go work cross-functionally to understand, how do we triage an inbox? Which ERP out of the 11 does it go to? And, really create more of the SOPs that Agentic AI can follow.
I feel like I've seen this before. I mean, enterprises talked about digital transformation for years, and suddenly it was all about the people and the people problems. So that's funny. But May, I was thinking of your org chart thing, and I hadn't thought of that. Like suddenly we're talking about how this is going to impact the entire org strategy, the organizational charts. I mean, how is that going to work?
I'll give you an example from our business, because I think one thing that we probably have all in common is building and scaling a generative AI company. You are in constant 0 to 1 mode. Doesn't matter how big you get. And we can have somebody on our customer team literally build a working prototype of a feature that goes directly to engineering now, right? Like it is a real cross-functional change, even in our own organization, how much more productivity, how much more leverage we have given every single employee in the organization. But you have to be willing to have an org that can do that, and that can skip steps and skip org levels and not really care about the org chart. And that is not the enterprise. And we have seen a lot more success choosing greenfield opportunities that become the story that everybody can rally around of what you can do when you build grounds up agentic first, AI first, because that, first of all, doesn't make anybody angry or upset. There are no politics. And it really demonstrates, how you have to really think cross-functionally and outcome-oriented. And if you were building your company today, how would you build it? It'd be very different than a lot of the multi-hundred-year organizations we're working with.
Yeah, I think all of us are going to become managers of AI. And most people right now are individual contributors. And it actually turns out it's a skill to manage. And you have to learn how to, in very disambiguated, contextually aware ways, train someone, know how to evaluate them, know when you can trust them, and just let it run. And I think we're going to all go through those same learning steps with AI agents.
This question is for everybody. I'm going from here to Las Vegas to Black Hat and to DEF CON, and I was really thinking about Dr. Song's security and safety issues. And there are so many Agentic AI sessions at Black Hat this year. How is that going to be dealt with? I'm wondering if you could each speak on that, particularly for the enterprise customer.
Yeah, and especially with multi-agent systems. What's happened, and I'm going to give one example. Like, we built many agents, multi-agent systems at Google. Some of them have million calls to make some decisions. And each of those calls have some risk around security, privacy, ethics, safety, etc. And now all of a sudden, instead of just one call, you have so many that risk is exploding. So I think we need to really look at component by component and make sure that at every single component level, it's more or less as close to 100% as possible in all of these values. And of course, security and privacy is a big focus area for Google and I'm sure for all the companies.
Yeah, I will add to that. I think in enterprises, a lot of information is actually governed. It's private in nature. There are a few people, maybe in a specific department that can access some information, but not others. So when you think about like bringing AI and AI agents in the enterprise, that's the first thing that you have to actually think about. Like, is this agent, like, is it running on behalf of a human? And if so, it should only have access to the information that that particular human has access to inside the enterprise. And so you have to make sure that these governance restrictions are actually followed in the enterprise. That's one key challenge, and you have to sort of absolutely make sure that your agent frameworks are capable of handling that. But the interesting one that we actually realize often, like we hear from especially the largest of the companies, is that they'll come and tell us that, well, we don't trust our own governance. We have lots of sensitive information inside the company. We haven't set correct permissions on our own data. Like if AI made everything so easy to access, we're really scared of that world. We're scared of what people are going to find. And so when you think about AI systems, you have to actually go beyond the active governance mechanisms that you have in place, but actually make AI smart and understand the context of what an agent is supposed to do and what information, even if it had access to it, you should not be making use of. So those are some interesting challenges with security in Agentic.
There are a lot of startups to be built in this world. Again, another story from our experience when you connect Writer's action agent to our own Google Drive, right? What Arvind just described becomes a problem that we've got too. So what did we do before we gave everyone access to that? Well, made sure that there wasn't some Google sheet that had everyone's salary that was set to only people with this link can discover, which Agentic AI is going to get really good at discovering very quickly. So exactly how do you productize that kind of security vulnerability discovery in preparation for true agentic rollouts? No one has really solved that at scale.
I think we're going to try the new microphone. It's number 6. All right, thank you. So short term, I agree. There are a lot of security concerns because the cost of finding one vulnerability is fairly small, and it's just going to get smaller with Agentic AI. Now, long term, as that cost gets so low, you can actually have every company run millions and millions of attacks against itself and then harden the system. And so as the cost gets so low that you can do that at scale for yourself, you can actually inoculate your systems much, much better. And then I'm actually long-term more optimistic again than a lot of other people.
All right, last lightning round. In a few words, what's one lesson about deploying real-world agents that you think academic folks should really understand? I've stumped them.
We're hiring, by the way, everywhere on all groups. May at writer.com. I think that the data is really messy. It's overlapping. The same data lives in multiple systems, and that's one problem. And the ability to delegate for an agent is a whole new paradigm that most folks are not prepared for.
Yeah, I guess I second this, but Richard at u.com for hiring. I believe that all the different infrastructure layers of Agentic AI that we know are needed, it makes a lot of sense to work inside each of them a lot more. And so for us, it was kind of search over public and some private data too. But I think in terms of research, what a lot of folks are underestimating is the power of these models to program and to actually run coding loops in a much deeper way inside the model. So, SQL queries, for instance, are a great example. No one is really doing that at scale at very deep inference times of the model. You usually take these large language models, you ask them to write some code, you let that code run, you get some output, and then maybe you iterate. But I think there's a lot more deeper work you can do in coding.
From our side, I think one of the key challenges with agents, again, is their accuracy and like making sure that they don't take actions, especially mutative actions inside the enterprise that can wreak havoc. And so I think the answer for any agent company when they go and sell their products, including us, we'll always say that, hey, put a human in the loop, put guardrails, not let agents take actions, before humans confirm. But I think for academics, that's the area that we need the most help on, which is citations, verifiability, and how do you actually get past that, where you have a lot more confidence in letting agents take actions autonomously.
Similar answer, actually. Especially when you're building your agents, you need to be able to know when you're improving versus when you're not. So your data is super critical, your ground truth is super critical, and probably self-evaluation and your agents having the ability to be able to self-evaluate is super critical. Otherwise, you'll improve your algorithms and agents, and you will not know if it's really improving. So that's going to be a big bottleneck if you don't set it up right in the first place.
Well, thank you to all our panelists. We will be taking a break, and we'll be coming back at 3:40. Thank you so much.
We're getting started in the next 10 seconds. If you can take a seat. And if you're Adarsh, Merquar CTO, if you can come to the front, that's great. All right. Hi, everybody. Good afternoon. My name is Vijay Reddy. I'm a partner at Mayfield Fund. We're a 55-year-old fund. We've raised over $1 billion. We invest early stages. And we've invested in over 550 companies and 120 IPOs. And I'm really excited to kick off the next discussion. It's a lot about agents in applications across enterprise and across consumer. The first speaker is Michele. He has a PhD in computer science. He is a postdoc from Stanford. And he's building the next generation of coding and software development infrastructure as president of Repl.it. Welcome, Michele.
Hi, everyone. In the next few minutes, I will try to convince you why we have been hearing about coding agents mostly in the last 6 months and why it doesn't happen for many, many years beforehand. As you recall, as a field, we have been working on this dream for many, many years. Automating software creation, of course, will unlock a lot of value. It turns out that we have been sitting on a flat exponential curve for several years. So this recent study showed that in the last 6 years, every 7 months, coding agents have doubled their level of autonomy. So for several years, the level of autonomy was very short. We're talking about a few seconds. And then just in the last 12 months, we've been seeing agents running for 5 minutes, 10 minutes, half an hour, just creating software and doing meaningful work. How did this happen? The the research field of agents has been around for decades at this point. They've been called expert systems, they've been called agents in several different places. But when it comes especially to code, maybe the first milestone, the first result that is very notable is in 2022, we had the React pattern, where rather than having LLMs use separately to create reasoning traces and also to act on an environment and obtain observations, we found a way to merge the two of them together. This is a result from Shunyu, who was an intern back then at Google, working on a model that I contributed to called Palm. It was a very powerful model, at least for the standards of 3 years ago. From 2022 until 2024, though, we haven't seen much happening in terms of products. None of you was likely using a coding agent daily for their productivity. And then in mid-2024, we have this paper called Agent, where for the first time, models were becoming powerful enough to make actions on a coding environment, use several different tools, such as how to search on the file system, how to view files, edit files, and so forth, run these tools, get back observations from the execution of the code, and then create a feedback loop with the LLM. This was maybe the inception and the first open source project to show that coding agents were actually possible. From there, though, very quickly, we added a lot of complexity to agent architectures. Starting from Agent, there was basically an instantiation of React. We went to multi-agent architectures, much more complex. We tried to separate different roles, having an editor agent, a manager agent, a verifier agent, and suddenly we found a bottleneck on how powerful systems were back in the days, and we haven't seen much improvement happening in the second half of 2024. The key insight is that imposing more structure in the core agent is actually harmful. So if you look at these curves, if you had more structure at the beginning, you actually see some improvement, but then you quickly plateau the performance of your agent. While what was happening in background, what the frontier AI labs were working on, was removing structure from the agent scaffolds and just allowing the models to become more proficient at deciding what are the next steps to be working on. Since then, most of the coding agents on the market embrace this new way of creating coding agents. There is this very interesting blog post from Anthropic dated December 2024, where they kind of go back to the initial architecture that I showed you from React, where we have an LLM and the IQ of the model at the center of the architecture. The model decides when to take actions and which actions to take to the environment. We close the feedback loop, and the LLM can take several actions in a row until it decides to either stop the work or heel back control to the user. If you use any coding agents yourself, this kind of user experience will sound very familiar to you. It's basically the key pattern behind Repl.it, Cloud Code, Cursor, Devin, and so forth. So where do we stand today? My premise, and I think many of you will agree with me, is that frontier models, especially when using massive RL scaling, are going to keep getting better and better as a whole, but especially on coherent, long tool-using agent trajectories. And as a consequence, what is left for companies and researchers that are actually building the agent scaffolds? There is still quite a lot of alpha to be generated just by the agent rather than exclusively the model. For instance, a key problem is how to manage the context. We have been approaching this by creating tools or sub-agents, basically ways to delegate a subset of the work to a separate component in the system, and then returning back the results and a small amount of information back into the main context. Then, of course, the quality of the environment is extremely important. The environment is what provides information back to the agent to understand if the necessary progress has been made, and at the same time, it also provides the infrastructure that determines the space of actions that the agent can take, so all the different tools and sub-agents that are available. And last but not least, agent builders can create stacks, can create integrations like data connectors, can bring in search agents. For example, the previous panel was talking quite a lot about that, parallelism, more powerful user experiences, and so forth. Now, there is still a gap between research and vibe coding, and that's one of the reasons why I'm here today, because I'm aware I'm talking in front of a lot of researchers. The vibe coders want maintainable and iterative development. That's how these products look like. But the truth is, most of our benchmarks today is work in this established setting where you go from an issue directly into a PR, So they just create diffs. And most of the popular repositories are extensible, and they already come with a structure. So it's a completely different problem to create PRs rather than just starting to create a piece of software from scratch. Also, the aesthetics matter a lot, and putting a human in the loop is really hard. I'm sure you experience model being way too sycophantic, and that's a problem that most of the technical users are facing today. So my call is we need more evals. The public available evals, such as Sweetbench, are limited. They're focused on a single task, while in reality, major product impact can be accomplished by being able to evaluate on app generation from scratch, front-end functionality, and especially long-term trajectories. So the philosophy that I'm following at Repl.it when building Repl.it agent is to bring less structure into the agent loop, but way more structure in the environment. If you're passionate about anything I'll talk about today, please come talk to me, because I'm hiring a lot of people as we speak. Thank you.
The next speaker is Karthik. So Karthik is the chief scientist at Sierra, which is a customer experience platform. He's also associate professor at Princeton, and he finished his PhD at MIT, and he was one of the authors of the GPT paper. And it's just a coincidence that the two papers you talked about today, React and SWE agent, that was Karthik's lab out of Princeton. So Karthik, take it away.
Thanks, Vijay. That was super nice. Hi, everyone. My name is Karthik, like Vijay said. Before I begin, I just want to quickly mention, I've spent most of my career in academia, but also have had the privilege of spending the last 2 years at Sierra, which is a growing company. So much of what I'll say will try to find a balance between, what's possible in the research world and, what's more practical, what is needed, right? So that's the title here today. So just to kick it off, why don't I just get a quick poll of the audience? How many of you here right now would trust an AI agent to completely do all your taxes? Just a quick show of hands. Okay, I see some hands, maybe around 20 hands, right? So that's quite low, right? And given that this is the Agentic AI conference, I'm assuming that's an optimistic estimate. And so the real reason I'm asking you the question is not because AI agents are not capable of doing your taxes. It's likely because you're not finding them fully trustworthy or fully reliable that many of you didn't raise your hands, right? And it's not just about taxes, right? Okay, they're boring, but even if you want to do your shopping or replying to your emails or whatnot, right? The key point that I'm trying to make here is not that AI agents are not capable enough, it's just that they're not reliable enough currently for us to be able to fully, give them that power. And so much of this talk, what I want to tell you is how do we get to that reliability, right? And by reliable, very quickly, I just want to break it down into two things that we'd want in our agents. The very first thing is we want them to be predictable, right? We want them to be consistently acting the way that we would predict them to act, right? And that's what you want for any autonomous system to do. And the second thing that you'd want them to be is aligned with what you want, right? And by alignment, I don't just mean, don't do unsafe actions or anything like that. But if you truly want your agent to be autonomous, do things for you, you'd want it to be aligned to what your tastes are, right? What would you do in a particular situation when new information comes in and you don't want to be bothered, right? So you want your agent to be both predictable and aligned, and that's what I'd sort of call, what the overarching phase of reliability in an agent. So I don't have too much time, so I'll just quickly run through, some points that I think are really, really important when you're thinking about adding reliability and, improving the reliability of your AI agents. To answer this question, the very first thing I would say, I know it's a boring thing likely, but really you want to be able to measure reliability, right? So, Peter Drucker has this famous quote, you can't really improve something if you can't measure it, right? And so the very first thing you'd want to do is have a way to measure the reliability of your system, right? And by system, I mean the entire system. It's not just about models. It's not just about tools. It's not just about any particular aspect of your AI agent. You want to be able to measure the reliability of the entire thing, right? And on top of that, you want to be able to design these evaluations to be both realistic in the sense that they're actually accomplishing the task that you want for them to be evaluated on, and more importantly, verify their reliability. So I'll give you two examples of work that we did and sort of tell you how that sort of fits in here. The first one is a benchmark called SweBench. So this was released almost 2 years ago now. And looking back, I just think through, 2 years ago, we had coding evals, right? And these coding models were just about to take off. And one thing that was missing in all these evals was they were just evaluating how well a model could write code. And that's not nearly what a software engineer's task is, right? So many software engineers likely in this room, your task is so much more than just typing on the keyboard and writing some code, right? And so what SweBench aimed to do was really go towards that realistic task, right? So, bug fixing is one realistic task. Let's go and try and evaluate that, right? And I'm not saying, that's the end of it, right? Just like Mikhail talked about before, you really want to be going towards whatever benchmarks suit your particular task. The second one example that I'll tell you is a benchmark that we introduced recently called TauBench last year at Sierra. And the benchmark here is actually very, very aligned with Sierra's use case, which is AI agents for customer support. But the important point that I want to mention here was we introduced this notion of a pass-hat-K metric, or pass-hat-K score, which really hits at the heart of what you need your agents to do for a task like customer support, right? So just imagine, in a task like customer support, you don't care about an average success rate when doing a task once. You care about answering the same type of query over and over again, 10,000 times, 100,000 times, million times, right? Whether it's a radio refresh or whatnot. So the pass-hat-K score over here was really aiming to tease apart the reliability part. And you can see the results. It already shows that many of these models with tool calling fail even when trying to do the same task 4 times. OK, so ideally, I've convinced you, you first want to measure what you're doing, right? On top of that, there's a bunch of different methods available in the literature right now that you can potentially look at beyond just looking at improving the base model itself, right? So the very first one, I would say, is actually really carefully designing your agent interfaces, right? So this includes the tools and whatnot, but also, as many others have mentioned before me, really thinking through what your context looks like, right? So context management broadly. There's other techniques. I won't go into details here, but things like self-evaluation and using memory and fine-tuning can be additional tools that you probably want in the back of your pocket when you're trying to improve the reliability of an agent. And again, assuming you have a good evaluation. I'll sort of, finally just conclude with, some promising directions that I see for the future, right? So these improve agents in general, but I do believe strongly that they can have a good impact on improving the reliability of agents. The first one is actually making them more proactive, right? So you want agents to tell you when they don't know an answer or when they need help from you, right? And not just react to whatever you say. And you also want them to be improving over time, right? So this is how humans sort of improve their skills and become more and more reliable over time. And that's a property that we'd want in our agents. And the second thing that I'd sort of say is, we're definitely going to move towards multi-agent networks. And the reason I think that's going to improve reliability is because you can have agents that verify each other and so on, and this will actually provide an added layer of trust. So I'll sort of end here. The future is bright. We're going to have AI agents working alongside us and operating alongside us. The key point, if you take one point from my talk, is it's not the capabilities of the agents that are going to keep going up that's going to be the most important. It's how well we can rely on them to do the things that matter and automate things that we care about. That's going to be most important. So I'll leave it with that. Thank you so much.
Thanks, Karthik. The next speaker is Adarsh. He's the CTO of Merquar. And Adarsh dropped out of his sophomore year at Harvard to start this company. It's one of the fastest growing AI recruiting platforms out there. Adarsh, come on board.
Cool. So I figured I'd start off with a little bit of context on the company. So Merquar automates a lot of these very manual processes associated with placing someone at a job opportunity, right? So reviewing a resume, conducting an interview, and matching a person. And we work with a lot of these foundational model companies as well as application layer companies at placing these really expert contractors who are driving model improvement through model post-training, evals, and whatnot. So what I wanted to talk about is a little bit more about what we've learned from working with these companies and what the actual bottlenecks are to creating better models, creating agents that work at scale, and whatnot. One of the most interesting trends that we've seen is a shift from compute bottlenecks to data bottlenecks, where these foundational models have gotten way, way smarter, and taking them to that next level of intelligence requires imbuing that intelligence in the model. And the post-training techniques that we're seeing a lot of these labs use is just changing very, very significantly. Maybe a simple example is we started off with supervised fine-tuning, which was essentially a prompt and completion pair. You do thousands of those, jam those in the model, and then the model would hopefully learn something. We then had other sorts of things like reinforcement learning from human feedback, which typically took the form of a test, right? You present the question, you have 4 possible answers, you pick the best one, and the model learns something. And now we're seeing this whole new category of thinking models and thinking agents and all of these sorts of things, where in order to improve the agent, you need to reward it really, really granularly via rubric, and reward it for going down specific reasoning chains. So this creates really, really massive demand for human data from experts, not crowd workers. And when you think of human data and just like data labeling in general, you might be thinking of, like, is this a hot dog? Is this not a hot dog? Like, is this a stop sign? Is this not a stop sign? Because that genuinely was what it was 5 years ago, right? But today it's much, much more so, we need the model to be better at Rust, and we need like the best Rust engineer to go ahead and teach the model how to do that. And finding that person is like a talent assessment problem, not a crowdsourcing problem. So Merquar works with all of these companies that are trying to make their agents better and their models better by placing the Rust engineers, the Olympiad medalists, the financial analysts, the chefs, the lawyers, the engineers, all of these people that are necessary to make models better. One interesting thing that we have learned is that a model is only as good as its eval. An agent is only as good as its eval, and that's also a topic that's come up here, right, with discussion of SWE-bench, all of these different eval frameworks and whatnot. Because in order to understand how well your agent is performing, you need to have an eval. All of modeling work just starts with evals. So one of the cool areas where Merquar is spending a significant amount of time is automating the process of sourcing, vetting, and placing experts at all of these different labs to make the models better. And the way that we've automated that is with our own agents, which we have our own evals for, that we've hired people from our own platform for. So it all sort of comes together. But we have a pool of 700,000 experts on our platform. And these are people across all the different domains that we've talked about. A powerful search over profiles, AI interviews, GitHubs, papers, and more. We're able to interview them at scale with an interview that understands their background, what's on their screen, the best question paths to go down, what the job opportunity is, which immediately filters down the people that we care about, and then we're able to place them at an opportunity. Over the next couple decades, work is really, really significantly going to change. The main barrier to applying agents and models to the whole economy is evals and improving them. And that's a talent assessment problem, and a lot of the smartest people in the world are going to be spending their time on creating these evals in the next couple decades. So Merquar is building the infrastructure to match and scale expert knowledge in the era of agents and the era of models by using a platform that can model every job, measure every skill, and optimize these matches between people, AI, and work. So that's Merquar, and if this interests you in any way, would love to chat more.
Thanks, Adarsh. Next speaker is Snehal. Snehal is the CEO of a company called Horizon 3. They're one of the leaders in AppSec testing and security use cases in AI. Snehal was the CTO of JSOC, the Joint Special Operations Command Unit. Prior to that, he was SVP at Splunk, and prior to that, CIO at GE Digital. So, Snehal, welcome.
All right. So I'm going to build a little bit on what Don had spoken earlier on AI agents and cybersecurity, in particular the use of AI agents for offensive cyber, so building AI hackers. That's something that we focus on and pioneered at Horizon 3 based on my time within the special operations and intelligence community, and then my time at Splunk, kind of bringing those worlds together. So when you think about AI for offensive cyber, there are two architectural paradigms that have started to emerge. One paradigm is iterative trial and error. And here you've got agents that are exploring step by step, like should I run this command? Did it work? Did it not work? Why didn't it work? How do I tweak or iterate on that command in order to achieve an objective? And then you've got this other approach around structured context and precision prompting. And in that other approach, you're using a variety of techniques to conduct reconnaissance of a target network, enumeration of that target network. You're building a knowledge graph that represents the facts of the environment. And then you're using queries of that knowledge graph to do very precise targeted reasoning problems with LLMs. Between those two, we've used both approaches. We ended up focusing on structured context for precision prompting. I'm going to talk about the differences between the two, at least in offensive cyber. So one, when you look at where we settled, kind of reading this, as you want to hack a network, hack Berkeley's environment or whatever, you need to first discover everything that's network reachable. Every host, port, service, credential, password policy, any other sets of things that are relevant to an attacker to achieve a compromise. And we'll end up organizing that data into a knowledge graph that represents the cyber terrain that we've discovered. And from that knowledge graph, we're going to start to find very targeted reasoning problems. One example is high-value targeting. We found a collection of hosts. What business department do those hosts belong to? Well, it's a targeted reasoning problem. You can't regex your way through that one. And what you want to understand is providing as much detail as you can via prompt to an LLM that says, based on discovered applications, credentials that have access to that server, and so on, we believe these services belong to the accounts receivables department. And the more precise you get in high-value targeting, the more accurate you are in compromising that particular host and understanding the business impact. The same for advanced data pilfering. You stumble onto a shared drive with 1 million files within it, you can't regex your way through those files. How do you use targeted reasoning to figure out that these files are actually 3D CAD drawings for Nimitz-class aircraft carriers, which is actually something our product Node Zero stole a couple of weeks ago from a defense industrial base supplier. From there, it's all about the right LLM for the job. Certain LLMs are really good at an advanced data pilfering problem. Other LLMs are good enough for high-value targeting. And you want to be able to have that selection of right prompt for the job, in partially because of managing costs. If you're a startup, scale up, understanding your gross margins and your costs of tokens becomes super important. And this is where we ended up using Bedrock as that model selector from Amazon. So based on the type of problem we want to go reason against, we can figure out which model in that moment is the best model to use for cost and performance, and then get the answer at a cheap price in order to be able to scale this out as a viable business. And for certain classes, Nova is good. For other classes, variations of Cloud are good. And the point is you want architectural flexibility. So a big question in offensive cyber is, can your hacker agent or attacker agent actually solve a meaningful problem? So for academics, a good range to try is GOAD, Game of Active Directory. Game of Active Directory is actually a pretty tricky cyber range to go off and solve algorithmically. One, you've got easy, medium, and hard. So GOAD hard, it's a 5 VM system. Everything in the hard mode is patched, so you're not using pre-2025 CVEs. You don't have legacy protocols you can exploit. It's a legitimately difficult range. And the reason why this is a hard range to solve for algorithms is you've got multi-step, multi-hop exploits. You've got to compromise machine 1 and use information from machine 1 to laterally maneuver to machine 2. Use information from machine 2 to abuse a trust domain into domain 2, and so on and so forth. You also have conditional execution. Based on a certain set of conditions, you can do one type of exploit. If some of those conditions are absent, you've got to try a different technique to get in. You have to discover and abuse trust. And you've got to do this with no prior knowledge of the environment. So there's no cheating, there's no predefined runbooks, there's no pre-known credentials. And you want to do this with no humans in the loop and no humans on the loop. You don't want to have a human nudge it. So it's an incredibly difficult problem for an agent to go solve. And when you think about an expert hacker, if you're OSCP certified with multiple years of experience and you're really good and seasoned, it should take you 12 to 16 hours to fully compromise the GOAT environment, compromising all 5 hosts, all 3 domains. For us, with Node Zero, it took 14 minutes and 25 seconds. That works out to about 50x faster than the best humans or the senior pen testers that are out there. So pretty good. Now that's a range. What does this look like in the real world? We run more pen tests today than consulting firms run a year. We ran more pen tests last year than the entire history of computing. Every one of those pen tests collecting telemetry to improve the underlying algorithms and decision making. And in the defense industrial base, and I'm keynoting Black Hat next week with NSA on this topic, you can look at some of the stats. Fastest to credential compromise was 5.5 minutes. 72 minutes was the median across real customer environments. It took 77 seconds to compromise a domain in the fastest. That means in 77 seconds, we've got keys to the kingdom. We can lock you out, steal your data, destroy your environment. So if your SOC can't detect and respond in 76 seconds, it's game over. This is super important as you build real-world agents. The final bit is when you look at the cost profile. So in structured reasoning, when you execute against an environment, 36,000 commands were executed to compromise at a cost of $3 to $10 when you factor in token costs, AWS costs, and so on. In trial and error, you needed to get through 20 to 80 iterations for each of those 36,000 commands. At 5 to 20,000 tokens per input output, that works out to $2,000 per test. So 700x more expensive if you go down the trial and error route versus the structured reasoning route. So I'll end there. I'm out of time. I hope this is a good sense of practical experiences in AI agents for offensive security and cyber generally. Look forward to the panel.
Yeah, I think we're going to get started on the panel section. Just out of curiosity, how many of you have wipe coded anything before? Right. That's a good crowd. How many of you have put agents into production? Okay, that's a smaller fraction. How many of these agents are in mission critical applications? Okay, that's about right. We'll get started. Maybe I'll just stand up here. So the first question is, we're seeing that there are going to be billions of agents, maybe more, right? Some predict 1 to 2 billion agents, probably tens of billions, maybe hundreds of billions of agents. Only 10% of them actually go from maybe demo to production, and maybe even fewer go into mission-critical applications. So when you have built agents in the past, where have you seen them failing? And what lessons have you learned?
I heard an agent deleted a database the other day.
Thank you, man.
Is it too soon? I don't know.
Too soon, yes. In case you didn't know, it's talking about Repl.it. So, can I give more details about it, though? It was an actual production database, and we could roll back. I don't want to make it sound as a cop, but I mean, I can break the ice, which I really did partially. Look, I think the agents that we're building are going to keep breaking almost on a monthly basis, and most of us are going through the process of refactoring them, maybe quarterly. There are articles. I think there is a blog post from Manus recently where they re-architected it 4 times over the last year. It's very similar for us. I don't think there is a clear recipe on how to make them stable and reliable over a long period of time. Like, we're really at the beginning, and the fact that models are evolving so fast means that we have to completely reconsider how agents are built. It's not like a steady, progression what we're going through here. There's a lot of work to be done from scratch. I don't know if you guys agree with me.
I'll build, at least in my world as an example, we're operating on production systems. So if you're going to execute a command against a production system, you better know what that command is going to do, because you don't want to take out that hospital network or that patient's device or the Swift server. And so you can't just use agents to throw a bunch of commands against the wall and see what sticks. There is a balance of discovery and determinism. And if you're going to actually touch a production system or touch a production database or whatever, how do you make sure you clearly understand exactly what you're doing in a way that's repeatable, that's debuggable? Most of these agents, at least on production system problems, I don't think have earned the right to do that just yet. And it's going to take a bit of time to build the trust against those kinds of production systems. Definitely for hacking and anything on the offensive cyber side, but anything related to modifying a system of record, the bar is very high for what an agent is allowed to do in that sense.
So I guess I'm interpreting your question, Vijay, as like what can go wrong and and in what ways can be prevented from going wrong. Yeah. Sierra actually has agents that touch production systems, like for example, like
customer wants to return their shoes that they bought or something. So the agent actually goes in and can change the system on the back end and do all of that. I think the way that we sort of accomplish it is just being really, really good about containerizing everything, right? And making sure that the agent has the tools that it can access, but then it doesn't have the direct tools, but there's sort of one level of indirection that usually helps. But I think for what's the worst that could have happened, I mean, in customer support, I think it's not as much about like individual conversations as much as you don't want that same mistake to be had over multiple conversations or whatnot, right? And if that happens over time, then it's obvious your agent is not actually reliable. If you have 100,000 calls, you want close to 100,000 of them to be actually successful. So it's really a matter of like being reliable at scale. That is the biggest challenge that I see, and I'm sure it's the same case in a lot of other domains as well.
I think for us, we've seen some kind of challenges at both like the intelligence level and then the infrastructure level. For context, one of our voice agents does these job interviews, right? And like if you're doing a job interview with a person, you don't want the person acting weirdly, and similarly, you don't want your AI agent acting weirdly. And back, over a year ago, when we were still running our AI interviewer on GPT 3.5, it just literally switched roles in the middle of the interview and was like, I'm no longer an interviewer. I'm, interviewing for the job. You interview me, right? And like that's just so embarrassing. But that sort of stuff happens, right? But there was like an intelligence problem where like GPT 3.5 was just not as smart as some of the models today, and we've naturally seen those kind of things approach zero. The second thing is like an engineering and infra problem, which is that for a voice agent, you need to transcribe the text based on what's said, then you need to make the LLM call, then you need to do the text-to-speech thing, and then you need to have all these fallbacks if any one of those steps goes wrong, and like all this is like a completely kind of like new production system that we haven't really seen before. So there's just some natural learning curve and guardrails and all of that in actually like implementing that successfully.
So each of you are hiring for staff building agents, right, across the board, maybe research, technical, engineering. So what kind of new roles have you seen come up, or you wish there was more people with that capabilities to build these agentic systems?
I'll say one from the more researcher perspective. Being a researcher myself, I think there's a lot of headroom for if you're interested in sort of like the cross between research and really understanding products and new experiences. So I actually think a lot of the future is going to belong to actually us dreaming about new interfaces. Right now it's chat. But is that how it's going to be staying for the next 5 years? I would be disappointed if that's the only way we interacted with agents, right? So I think there's this niche of like understanding the technical part, understanding the research, but also being able to, understand how interfaces work or how product works. I think that sort of combination would be really powerful in my opinion.
I would say in cybersecurity, most of the labor force in cybersecurity is very applied and very practitioner-centric. Rarely do you see that community of folks have advanced degrees in mathematics or statistics or any sort of significant machine learning or AI levels of experience. And on the flip side, rarely do you find folks with machine learning AI researchers that actually have deep subject matter expertise in cybersecurity and so on. So I think in cyber in particular, there's a really big chasm between practitioner knowledge and machine learning AI best practices and techniques. And I think it's going to be very difficult for that chasm to come closer together just because of how difficult it is to become an expert in a variety of these cybersecurity topics, and also how difficult it is to become an expert on the AI side.
I think there's a new category that we call AI engineers, at least most of us in the field are starting to call them in that way. And it's a combination of being, of course, like very strong software engineers, understanding the capabilities of frontier models and how to build agent scaffolds. And last but not least, have that kind of rigorous approach that a scientific researcher has, especially in evaluating and understanding why agents are behaving correctly or not. It's a trifecta that is very hard to find on the market yet. I don't think it's related on level of seniority oftentimes. It's mostly about like how much hands-on experience this candidate has had in building agents previously. And there is a scarcity on the market for that.
For us, I think this is maybe a little bit less directly relevant to agents, but more so AI code gen in general, we're actually building out a team dedicated to accelerating developer velocity with AI code gen tools. And that's just like something that I couldn't have predicted like a year ago. But even just implementing certain things in engineering workflows properly can just be like a 10, 20, 30, X, lever on productivity. And those things are sort of just like no-brainers to invest in.
I think we only have maybe 8 more minutes, so I'm going to ask each one question separately, right? So maybe Karthik, starting with you. You wear a unique hat of research and working at Sierra. As you look forward to the next couple of years, what is exciting for you in the research domain that you want to apply in real-world use cases?
I sort of, I guess I sort of alluded to that at the very end of the talk. I think the two main directions that's most interesting to me are agents that learn on their own and having agents communicate with each other. Because I think like one of the transformative things that AI agents can bring are automating a bunch of different tasks that humans do, but it's just impossible if they're not able to, one, improve on the job, and two, be able to coordinate with each other. So I personally view those as two areas where, obviously there's a ton of research happening even right now, but there's a lot to be done and a lot to be gotten right before we can sort of truly unleash agents, I guess.
Adarsh, you are working on the intersection of humans and AI, where agents and humans work very collaboratively with each other, right? What frameworks have you seen that works where, or at least directions which you're excited about, where humans and agents can live hand in hand, and how do you deal with that?
Yeah, I think most people have this model in their heads where it's like, I give an agent a task and they're going to go from like 0 to 100 and just like complete the task. That's actually not the model that I have for this sort of stuff. I feel like it's more of like a bidirectional relationship rather than a unidirectional one where you give an agent some work and maybe it gets you 70% of the way there, but then like that last 30% you need like an expert to go ahead and take it to 100%, or even in a non-expert context you might need to just intervene. So I think in the future there's going to be a huge premium on that 30%. And for all of us, it means that it's just going to unlock a whole new set of capabilities and things that we can do as we add agents into our workflows.
Snehal, you work on mission-critical applications, right? Some of it is offensive, but as you look at next generation of security and trust and safety, what are some things you would recommend people to look at to be safe and secure by design?
I think it goes back to, if you don't, as an overseer of those agents, understand what decisions were made, why they were made, and actually have points of interdiction as appropriate, it's going to be very hard to allow these agents to operate on critical systems. And the more of a black box you are, the harder it is to build trust between the human overseer and the agent. This, of course, assumes the agents don't overtake the world and we become subservient to them. It's a joke amongst the researchers. And so I think that explainability is going to be an incredibly important aspect of everything that you hear today, everything that you see today, and making sure that people understand what this thing is doing, so they can actually operationalize it properly.
And Michele, for coders, right? Right now, you're using, as Copilot, let's say, some of these cursor kind of tools or Repl.it kind of tools. At what point do you see humans becoming managers and agents doing all on their own? And at what point do you see maybe human doesn't have to do that as well?
I think we're already there for the former to an extent. We see a lot of people running multiple instances of agents in parallel, and they act mostly as managers and tech lead of this swarm of different agents that they are executing different PRs in parallel. It will take, of course, way more time to make that happen for non-technical users. And I do think the path towards completely replacing developers is much further away than we currently believe. This is coming from a person who's inherently techno-optimist, and I do think the AI is making incredible progress. But I think that as humans, we're adding that new abstraction layer every time, inventing new frameworks, inventing new way of creating better developer experience, as you were mentioning. And I don't see AI being there as we speak. So maybe that's the next level of accomplishment, and we're going to be getting with super intelligence. I don't know what's the timeline. I think what matters is to build in the present. And I think already the tools we have today are very useful in the present.
That's awesome. One last question for each of you. As you look at your own businesses, whether it's technology, whether it's people, or whether it's processes, what are you most excited about in your business?
I'll start. I think anyone that does a venture-backed security company or venture-backed company in general, how do you go from a really interesting idea to a repeatable sales motion to efficient growth at scale? And I think that, one, how do I, as a CEO of my team, allow them to explore, be AI developer first? We're big users of Repl.it as an example. Embrace how to change the way that they operate. How do I incorporate the latest capabilities into the product? But how do we also keep an eye for efficiency, whether it's gross margins, rule of 40, and so on? Because it's one thing to be a startup in the early stage. It's another to be able to make sure you can scale to a point where you've got the business metrics to build an IPO-able company. And I think for us at Horizon 3, we've really done a good job of balancing exploratory research and pursuing and really defining a category that's really hard to build against, which is offensive cyber, with making sure we do so in a financially responsible way, so we actually have an economically viable path to an outcome.
I can go next. So Sierra's main goal right now is to build agents for the enterprise, and we're starting with customer support. But I actually think the most exciting part lies in the future, where you can think of for any enterprise, any sort of engagement that they have with their customer will go through an AI agent. So there's sort of this huge potential space where everything you do, you have your website, you're selling stuff or whatnot, right? Everything goes through an AI agent, and that sort of offers both from the enterprise side a way to have personalized support for different users or your customers, but at the same time offers for the customers a more personalized experience, right? So you don't have to wait on the phone or wait to chat with a human on the other side. So I think it's a cool problem both from the business standpoint, but also from the technical standpoint, because this is a use case where you can imagine the holy grail vision of being able to talk to an AI system and be able to do things. Like it's a very, very realistic thing that is up and coming right now, right? It's happening right now, and the space is just ripe for it. So I think that's super exciting, and I think that's going to be a very, very exciting thing for the next few years.
I think for me, there's a lot of things to be excited about, but one thing just reflecting on the journey is 2.5 years ago, I was taking computer science classes in college before I dropped out. And you fast forward those 2.5 years, and now Merquar does several hundreds of million in revenue run rate, and is growing really quickly. And I think that whole experience is extremely jarring, right? And you learn a lot of things along the way. And I think that has been one of the most exciting things for me, just like as a personal thing. But for the company, what I'm the most excited about is this new wave of RL, where the models, in order to get more and more sophisticated and think deeper and think harder, need to get rewarded for more granular reasoning chains. And the way that we're seeing all of the labs kind of approach this problem is through these really, really detailed rubrics that reward those reasoning chains and often require a lot of human expertise to craft them. Or even for computer use or like code execution and things like that, you need to define these RL environments, which define the optimal start state, end state, and how you're going to reward and eval the model for all these economically valuable things. So I think that's what I'm most excited about.
I believe in the past few months, we proved that it's going to be possible to give coding skills to any knowledge worker. And I find that extremely exciting because we can turn every person into a generalist. I think that's going to bring a lot of abundance in the world, and the boundaries of what professional roles are will really blur out over time. And that really matches our company mission, as you know.
Awesome. I want to thank the panelists, Mikhail, Karthik, Adarsh, and Snehal. So give them a round of applause. Thank you. Thanks, guys. And the next event is going to be Don and Vinod. So a request to come on stage, and thanks again.
Yeah, thanks everyone for being here. I hope everyone have really enjoyed the summit today. And now this is, we are coming to the final session of the summit. We'll close out with a fireside chat with Vinod Khosla, someone who actually doesn't need an introduction. Vinod, of course, everyone knows has been truly a pioneer in the VC space. Has really helped a lot of entrepreneurs to grow their startups, the businesses, has made huge impact in the world. And in particular, actually in the AI space. So Vinod, yes, so you actually have been investing in AI for nearly 20 years. That's a long time.
Well, more than AI is more recent, but
yes. Okay.
2018 for sure when we invested in OpenAI.
Right? Yes. So yes, given your long-term experience, it'll be great. First, maybe you can share a little bit the lessons that you've learned with investing in AI over the years, and also in particular, given that now we are coming to the Agentic AI era. So, what do you think? What's making the difference, and what's going to be the big changes and big differences coming?
So the first thing I'd say is it's exciting to see so many people show up on a Saturday afternoon. It's sort of the vibrancy of the place that really excites me. But I think it's the key to rapid progress. So one of the ways I look at what areas will have large breakthroughs is look at universities and say, where is the best talent going? And in the 2018 timeframe, and I started talking about AI probably seriously in 2011, 2012. Made our first few investments in 2014 or so, didn't work out. That was the era of ImageNet. But if you see the progress of talent coming in, you see the story of diversification of new ideas. And so the more people, smart people working on it at universities, the faster the rate of progress is going to be. Also, that doesn't happen if most of the talent is at the big companies and the big labs. Why? Because they tend to do narrow exploration in a narrow domain as opposed to look more widely. So I find the more university students, individual researchers, individual just hackers working at a problem, the faster the rate of progress. And that's always really exciting.
Oh, great, thanks. And thanks a lot for saying this. It's really great to hear, especially given the current time and setting. I think there is a big question, given the amount of compute and resources that are needed to develop these new technologies. More and more, things are happening at in these big companies, are places with a lot of resources, and then in general now they actually are fairly closed, Don't talk about what they do and don't share with the public, and so there is a big question, It's great to hear that you're talking about the importance of the university, and open research and open exploration.
So I get asked this question a lot. I think the big labs will do well and make progress within narrower areas. Everybody knows transformer models. Everybody knows to use RL in one form or another. They'll do that pretty well. Are there other approaches? Absolutely. those are much higher risk, but higher upside in bang for the buck. So for people with fewer resources, I'm almost certain that lack of resources is an advantage, not a disadvantage. I was just meeting with somebody, and I literally said, if you had 10 or 100 times the money, you would be less likely to innovate than if you had less money. I'm absolutely convinced. So are there other approaches than transformer models? I'm pretty certain there are. And just because we don't know what they are doesn't mean they don't exist. And lots of people have lots of ideas of how to try things. And at every level, we'll see that innovation.
Great. Yeah, it's really great to hear this. I guess there's a saying, necessity is a mother of creativity. So I think this really gives a great inspiration for people in universities and places with less resources. That's right, better motivation for creativity.
Yeah, no, look, if you're at Google and you're doing a robotics model, and you've already done a VLM and you're doing a new model, what's the obvious thing to do? Oh, let's collect lots of data. How do we do it? Let's get 100 robots or 1,000 robots. And because they can afford it, they get lazy about finding other ways to get much better or more efficient data. So they buy 1,000 robot arms because they can afford it. And it makes the researchers lazy and less creative looking for new solutions. And that's where necessity is the mother of invention idea really is powerful. If you have less resources within bounds, you're more likely to come up with more invention and innovation than if you have lots of resources.
Yeah, great. Thank you. This is a great message for
Which is
for
good
the audience.
news for everybody here, hopefully.
Right. No, thank you. Yes, I guess, right. Then, right, so you started investing in OpenAI like very early in the OpenAI's early days. I guess back then also maybe it's a little bit of this, like they are exploring and so on. So maybe, right, you can share a little bit how you decided to invest in OpenAI, and now today, and also, usually investments, you do some pattern matching, so what kind of patterns, in particular for today's founders and builders and so on. So yes, what do you think?
It was actually, not that complex. I looked at the world then in 2018. There was 2 research labs in AI that mattered. There was university research, but there was Google, and there was Baidu in China. And I thought the world needed more than those 2. And because Google wasn't moving very fast to make AI pragmatic or practical, they were doing great research, and they probably still have the best repertoire of researchers. They have very good talent. But they were moving at their own pace, no real pressure. And Baidu was doing basically copying Google and set up an office next to Google and try and hire their people and look at what they're doing. I thought it was really important we have a different vector, which was OpenAI. And what was needed was a small, really good team. And it was a small, really great team that wanted to move fast. And those were the only characteristics needed. You could also look at, in 2016, I'd given a talk at the National Bureau of Economic Research, and I'd shown the curves of progress on AI capability in different dimensions against human performance, whether it's speech recognition or image recognition. There's probably 20 curves, and they were all looked silly compared to human performance, but the rate of growth of capability was exponential. So instead of saying what people believed, what other people believed, and saying, hey, these robots are silly. They ask an 83-year-old man if they're pregnant. And AI made stupid mistakes like that. I said, what's the rate of change? And when you follow that curve, it was obvious it was only a matter of time before AI exceeded human capability in any of these dimensions. So you follow the data instead of ask the experts. And by the way, in this talk, I included a graph from about 50 people, their projections of AGI, and they varied from 5 years to 500 years or never. And I said, expert opinion doesn't matter. What matters is just keep innovating step by step and see where it gets you. And the rate of progress is accelerating because the rate of talent input is progressing and the rate of creativity is progressing. And it was obvious to me at some point soon, and I couldn't predict whether that'd be 3 years, and it happened in 2022 with the ChatGPT moment from my point of view. Whether it was then or 5 or 7 years later, when the breakthrough, when it got to pragmatic, useful capability, I didn't know. I didn't need to project. I just knew it would happen. And when it happened, it would be large enough, so it wouldn't matter whether you were early or late. Well, being late would be a problem, but being early wouldn't be a problem. So that was sort of the whole thinking of why it made sense. And I think we're in the same place in robotics today. This morning, anybody watch my tweet this morning? So I tweeted something that most of you won't believe today, that before 2030, we will stop using keyboards and speech for input into computers. Now, anybody believe me? A few hands. For the rest of you, I'll give you 2-to-1 odds on any bet you want to place for any amount. Before 2030, we will be reading thoughts, and it'll be multimodal. It won't be text, it won't be speech, it'll be images. Now, that was my tweet this morning. So go look it up and tell me you don't believe it, and most people won't believe it, but it's clear where progression, where the data is indicating things are going.
Thank you, thank you. Yeah, this is really amazing. So you said you gave that talk back in 2016, right? Charting the progress of towards AGI and so on. Yeah, that's really impressive. So
and look, the important thing was not to predict a specific method, right? You couldn't say transformers were going to be it. You couldn't say RL was going to be it. You had to believe with the creativity of all the people trying all the things, that you'd get a steady rate of progress. It's just like evolution in biology. You can't predict the path of evolution. You know it will happen.
Mm-hmm. Yeah, that's great. So I want to get back
by the way, in biology, you do see punctuated equilibrium where you get to a point and then you get this sudden increase in capability, right. And punctuated equilibrium. That thing is happening in AI also and is a good model.
Yes, great. Yeah, thank you. So yes, I want to come back to this point, but I wanted to just double click a little bit of one point that you made. You said actually it doesn't matter if it's early. Although we do know that in the startup world, timing, people do say timing is almost everything. So I wanted to hear a little bit of your thoughts.
Yeah. So that depends on what you're doing. If you're doing an application, like a coding agent that's just using OpenAI or Anthropic LLMs to do coding, timing matters. So applications capturing the user mindshare matters. So whether you're the first accountant or the first structural engineer or the first oncologist or the first coder, their timing matters because you gain mindshare and you get learning and data from interaction early. In fundamental innovation, for example, I've tweeted probably 2 years ago, I'm pretty excited about what category theory could do for new models of AI learning, could you eliminate hallucination, which is one of the bigger problems. If I look at the problems in AI systems today, hallucinations sticks out as one of the bigger ones. Safety is another one. We can come back and talk about it. But if mathematical approaches can add to what LLMs, the dimensions LLMs are really good at, then you've got large breakthroughs. You solve the problem with reasoning systems, have recently added the ability, but we are still talking about, can you give it a 20-minute task or a 30-minute task in agentic systems? Almost certainly, the time horizon for agentic action will increase exponentially over the next few years, and much of it will come from new breakthroughs in approaches.
Great, thank you. So yes, this leads to the next question. So the AI space has changed a lot, and it's changing really fast. And you have been amazing investor VC. So let's say if now you have $500 million new fund for investing in AI, what would you do? I mean, of course, in AI, there are many different parts to it. There's the core foundation models that takes a huge amount of resources, billions of dollars of investment to do. And there is various infrastructure, like today in the summit, we actually talked a lot about all the different layers of the stack. And there's an application layer, different verticals and so on. So what would you do if you have a $500 million new fund?
Yeah, so I don't look at it that way. So one thing everybody should know is in 40 years, I've never called myself an investor, ever. I think the business of investing is different than the business of helping innovation and helping entrepreneurs innovate. It's a fundamentally different approach than investing. That's why I never called myself an investor. But let me give you a counterexample. If we had had this conversation last year, and somebody said to me, hey, the best approach for brain-computer interface is what Neuralink is doing, or we have a company called Synchron, invasive approaches. I just said, I can't think of a better one. Today, I'm almost certain all of those are already obsolete, and Neuralink will be obsolete, though people don't know it yet. And non-invasive, large-scale approaches with large-scale data will be a much better approach in the next year or two. Like exceeding Neuralink or even our company's capabilities in the next year with a non-invasive approach is a done deal already. So, the point I'm making is the most important thing is not to have a thesis, but to have agility to follow the thesis and stay engaged and talk to the kind of people in this room. And anytime somebody has a new thesis that has a reasonable basis, I want to hear it. Say, where could it potentially lead? The way I say it, improbables are not unimportant. I would argue only the improbables are important. We just don't happen to know which of 1,000 improbable ideas in this room is important. So not knowing which one's important doesn't mean improbables are not important. And so this is where diversity of thinking around innovation, whether it's agentic systems or other systems, is really, really important, and not to have a closed mind, have real agility in thinking about these things. And that's what I do, right? I tell people, and there's a lot of younger people in this room, I just turned 70. I've never in my entire life, in the last 50 years I've been learning, had a faster rate of learning than today.
Yeah,
that's pretty amazing.
Yes, absolutely. Yeah, thank you. Great, thanks. So yes, AI is moving really fast. building on this.
So be agile.
Yes, be agile. Yes. So.
And open-minded, by the way. Lots of agile people are not. Too many people who know too much about a space tend not to be open-minded.
Yes, great, thank you. Yes, so yeah, AI is moving really fast, and in your essay, AI dystopia or utopia, you projected that 80% of the work in 80% of jobs will be done by AI within 25 years. And also, actually, recently, earlier this year at Davos, I was on a panel with Demis, founder and CEO of Google DeepMind. And the first question to the panel was, how far are we to AGI? So I'm curious to hear.
Yeah. You know, AGI is a funny thing. If you use the old Turing test, we are well past AGI already. And whenever you get a capability, somebody moves the goalpost on what AGI is. So I think it's the wrong question. Or I define AGI, at least at the human level of AGI, differently, and ASI, the human superintelligence, is a whole different thing, as the following. If an AI can do 80% of the most valuable, economically valuable 80% of jobs, then I'll call that AI. So economically valuable jobs, if 80% of them can be done by an AI, then we are at that point of dramatic economic value add by an AI, and we shouldn't argue about what the goalpost or benchmark is. I don't need to have to be the best at the IMO to reach that level. Most humans don't come close. 99.9% of the humans don't come close to solving math theorems. So that's a really important capability to have. But to do valuable jobs, we're getting pretty close. Whether we are, and I'll be clear about the capability. The capability to do most of these jobs is there today, especially if you put it at, can we do 80% of all jobs humans do? We're probably there today with a year or two of tweaking current capability into doing that job. Can we take what is in today's state-of-the-art AI models and turn them into an accountant or a structural engineer or pick your favorite oncologist? Yes, we are there today. The capability exists today. The packaging may not be there, but we can package very quickly, and that's lots of opportunity in applications for this group. Whether you call them AI systems or agentic systems, to me, that differentiation will go away. Now, the more important question is not when we have that capability, it's how fast will it be deployed in real life. And that will take longer and vary dramatically by the area, by the country it's in, by the competitive pressures in that industry. So deployment is a separate thing from the capability being available, but capability in 80% of jobs, probably in the next 2 years or 3 years, if some entrepreneur decides to package it. Today, we are building AI accountants. In our portfolio, building AI accountants, AI structural engineers, AI mental health therapists, AI oncologists, AI primary care doctors, AI chip designers, AI analog chip design. Like, all of these are things we are already doing and are reasonably useful at the level, or AI in a place like cognition, AI software engineers. At the level of interns, these capabilities are there today.
Yes.
And they'll be at the level of a good engineer in the next year or two in all these areas, or a good physician, or a good...
Great, great. Yes, yes. Yeah, so similarly, so from the panel, so Damon said 5 years similarly, and essentially from the panel we said there's around 5 years, or there's some maybe 2 to 10 years and so on. So I think the question is, yes, we know that the AI capabilities are already very strong and they are increasing really fast, and this can lead to huge changes in society. And you have spoken quite a bit on this topic as well, so maybe you can also share some insights, right, in this space.
Well, so this is the hard question. Adoption of these technologies will be less a function of AI capability and more a function of politics, more a function of what policy allows in a country, what are the safety nets for people. Look, democracy, capitalism will drive these things, but capitalism is by permission of democracy. I can guarantee you the American Medical Association is fighting to not have AI do medical diagnosis. Even though it's proven AI today, even without fine-grained packaging and guardrails and all that, can do substantially better than humans. Stanford just did a multi-center study on complex diagnosis, not the simple stuff, you have flu, but complex diagnosis. Human accuracy across 3 major medical centers was 73%, which means 27% of the patients got the wrong diagnosis or a suboptimal diagnosis. Think about it, for serious complex conditions. The AI was at 88%, so only 12% error rate. When the humans used the AI, they improved from 73 to 76%, but they degraded the AI from 88% to 76%. That is the reality of human behavior in and AI today. In many, many areas, not in all areas, but in most areas, very, very soon.
Yes, yeah. Thank you. Right. Yeah, this is a great point. How we can actually really deploy AI capabilities effectively and also with safety and security guarantees.
Look, the Screen Actors Guild had a strike last year, preventing a bunch of companies from using AI in entertainment effectively. So what has happened? It has ensured that the people who stick with the contract with the Screen Actors Guild will go out of business. It'll take them longer to go out of business than adapt AI directly. It's a great opportunity for startups to do new forms of entertainment with AI. Whether you're producing a video, a commercial, a new kind of video game, it'll come from startups that didn't sign up to the Screen Actors Guild. Big opportunity.
Great, great. Thank you, thank you. So now we are coming towards the end. Maybe just one final question. If you could just offer one piece of advice to the next generation of agentic AI builders, what would it be?
I would say the simple thing. Most people are limited not by what they can do, but what they think they can do. So if you take the limits off on what you think you can do and try things, then you will do a lot more. You will fail a lot more, but you will achieve a lot more. I would say skeptics never do the impossible. Every time I tweet something, there's skeptics saying, oh, I tried this last year or 3 years ago, and give me a break. Go live in that world, fine. And we should allow people to live in a world without AI, if they choose, but they shouldn't constrain how other people who want to use AI use AI. So I would say skeptics never did the impossible, and all of you should try and fail, but do not fail to try. Thank you very much.
Thank you so much. So with that, we've concluded our fireside. People, please still stay in your seats. We have so we concluded the fireside chat, but now we have the final part of the program, which is a startup spotlight. We have actually a couple dozen really exciting startups. They will be doing their spotlight to introduce you the amazing technologies and products they have been building. Right.
Hey, Don, can I just say I'm going to have to run soon, but feel free to email me. My email address is vk@Khosla If you try and catch me in the hall, I'll forget everything you said. So better to email me. Thank you.
Right. Thank you so much. And for the startup spotlight for the founders, please line up on the other side of the room. We'll be starting now. Huh? Yeah. The speakers for the startup spotlight, please line up against that side of the wall. And they're going to speak here. Yes. And we'll be starting the session now. So for people, please do take your seat. Very short. It's a minute or a couple minutes. They should have the order, and you can see. Okay, we'll be starting in just a minute. People, please do take your seats. We have some really exciting startups in the Agentic AI space. Yes. And again, for the speakers, for the startup spotlight, please line up on the other side of the wall. Thank you. And we are starting the session now, so please, people, take your seats. Thank you.
I can start? Okay. Hi, everyone. I'm Joy from Heijian. I'm very excited to be the speaker today, one of the speakers in this startup spotlight session. And I really want to introduce my company, Heijian. We are building an all-in-one video generation platform. And today, we have around 80,000 business users around the world. And they are trying to use AI to help them to create studio quality videos in minutes. Previously, I have prepared a video, but today, unfortunately, I cannot show it. But I have some screenshots. I think it can give you a direct sense what we are building. In the past 3 years, actually, one of my main job is actually I talk with a lot of business owners, creators, individual creators, educators, try to understand their pinpoint and challenge when they want to create video content, because we think video is an engaging format, be part of the communication. I think most of the challenge we heard from the customer is when they want to create a video, actually it costs a lot of time and money. Because it usually need a professional crew, a professional camera, and also the post-production takes a lot of time and money. Please help me to switch to the next slide, please. Oh, sorry. I can do it myself? Oh, this is my video. I think we can play it here.
beach surrounded by nature. Hi everyone, I'm Joy from HeyGen, and what you're seeing and hearing right now is my AI-generated avatar and cloned voice. I can create my avatar standing on the beach, surrounded by nature. With HeyGen, I can also make my avatar speak different languages, like Spanish. Vamos a construir algo increíble juntos y dar vida a ideas que marquen la diferencia.
Thank you. Yeah, that is an example about what we are building. Actually, this video is created by my AI avatar and voice clone, and I cannot speak like Spanish. And how we can create this type of avatar is actually I submit a 2-minute video footage, and I can train an avatar. And each time, if I want to create new videos, I can directly type the script to generate that videos, and also I can create videos in different languages. And people use it for the corporate, they use it for internal training, internal communications, also external marketing. This is one of the HeyGen's core functionality. Another functionality is video translation. So video translation is actually help people to localize content very easily. You can directly upload your videos, and it can directly help you to translate videos, use original voice tone, and also can with the lip sync to match the target language. And today we support around 70 different languages and 150 plus different locales. The third one feature we call it interactive avatar. Interactive avatar, I think for today's topic is related to AI agent. We see some of our customers, they actually use HeyGen interactive avatar API as the visual layer of their AI agent. So previously, for video avatar is video format. Interactive avatar, actually, you can build up that kind of live chat, interactive avatar experience, and you can directly adding it on top of your AI agent solution. And this summer, our team are also very excited to launch a new feature called Video Agent. So for Video Agent, we think the workflow is also very different. Like you can just tap a prompt, write your video ideas, and HeyGen can help you to generate the end-to-end video. And you can upload your B-roll footage, the document, and AI will help you to write the script and also help you to generate the B-roll footage to support your storytelling, to generate that video asset and to generate that draft. Okay. Thank you. I think, yeah. And if you are interested and want to join the waiting list, can scan this code.
Next up, we have startup number 2, Revify.
All right, let's load the slides. Okay, I see it here. All right, folks, I'm Girish. I'm with a company called Revify. What we offer is an AI agent for data spend optimization. How many of you here use a cloud data platform such as Snowflake, Databricks, Google BigQuery, or AWS Redshift? Okay, a few of them. And this is really for you. So what our AI agent does is it automatically identifies anomalies from queries, spend, performance, and quality, and has either you can use it as human in the loop, or you can use it in a fully automated fashion. All right. So what are the challenges data practitioners experience today? There's lots of data, and AI is making it worse, contrary to what everyone tells you, right? Cloud costs continue to spiral, mostly because of consumption-based pricing models. And there's a lack of talent, both from a data engineering perspective and from understanding newer platforms, because everyone is introducing new features every day. It's practically impossible to keep up. And management is just not reacting fast enough, or rather they're reactive but not strategic enough to fix the problems. So what's the current problem? Hey, do it yourself. I have the smartest engineers. You just cannot keep up, folks, because it's expensive and it takes time, right? And native tools. data platform vendor, I won't call out anyone, there is no incentive to actually solve it in a multi-cloud perspective. Consulting is just expensive, and the status quo just won't cut it anymore. So if you look at the graph, I've switched the BCG matrix and said the one on the left is actually, the y-axis is the effectiveness, and the x-axis is time to implement. It's really, really fast with a Revify. Why is that? Because what we offer is a single agent. It's at the nexus of 5 pillars: spend, performance, quality, usage, and also observability. And our customers get roughly about 50 to 70% savings in spend, and it takes only 5 minutes to get started. And what makes us unique? Yes, it is AI, but we use lots of statistical models, ML. It's zero touch, and it is a self-tuning and self-driving model. Think Tesla, for example. And it's a provable results. Our customers have saved anywhere from $3 to $10 million, and it's provable right within the product. So who are we? We are a 2-year-old startup. We have some marquee logos as customers. Hit me at revify.com, and more importantly, make sure everyone takes a picture and goes to the website. My incentive is tied to this, folks. Thank you all.
Thanks so much. Now we have startup number 3, Semaphore AI.
Thank you. Hi, everyone. My name's Ram. I'm a co-founder at Semaphore. I want to talk to you today a little bit about what we're doing in the enterprise agent space. Firstly, what problem are we solving? The problem is basically, if you think of every enterprise kind of looks like the bottom layer. They don't have one of anything anymore. They got 5 different data lakes, 20 petabytes of data, 7 different line of business systems, a couple workflow systems, and then all the real work gets done by people in Excel or in Google Sheets, right? So that's the layer cake that you have. RPA was supposed to be the previous generation of automation. There's a lot of issues with the brittleness and the rigidity of that kind of automation, which means that if you just follow the money, you take a large bank, where do they spend their money in the different layers here? 1x goes to RPA. They spend 10 times as much on data. And that's kind of the space I come from. So we were the folks who created commercialized Hadoop in our previous lifetime, right, at Hortonworks and Cloudera. We noticed that even though they were spending a bunch with us on the data layer, there were 10 times as many people-related process spend just around how they manage the data. How do you get from like all these insights? How do you do something with them? That has been traditionally only the domain of human analysts, right? So what we are going after is how do you build agents that can attack that kind of knowledge work? That's the big opportunity that we see. So if you think of this kind of knowledge work, what it breaks down to is just understanding the work in English. That's sort of the central thesis. If you don't know the work, you can't do the work, right? So the reason we kind of launched Semaphore was said, this is an opportunity for us to extract meaning from 3 different places. One is the meaning of the work, that's in English. The second is the meaning of the data, right? This is a semantic data model, hence Semaphore. And the third piece is the meaning of the outcomes that you want in these other systems, right? So before MCP, so basically we had a comprehensive framework for automation as code in Python. Now that entire layer is MCP based. So our agents are essentially, think of them as combinations of English, SQL, and Python. In an enterprise context, we provide this end-to-end platform. The way we think of this is we like to say the bookends are it's built by a business user, and it's used by a business user. And then the stuff in the middle is just agents that work like software, right? So the idea is that you're not going to take humans out of the loop for these really complex processes, but you can make them hyper-efficient. So there's a whole bunch of information on demos and so on from our website. We're also in Docker Desktop, so that's the easiest way to experience one of our agents is make one of them. I guarantee you'll do that in 5 minutes for a very simple process. You can download Studio. This is our way to actually construct an agent that's also available directly from our website. So we are super excited about how you can actually go after a very large swath of business-centric workflows with this kind of an agentic approach. Thank you.
Thank you. Now we have startup number 5, Newbird AI.
Hello, everyone. My name is Madhav Shah. I'm a founding engineer here at Newbird, and we're building the next big step in enterprise IT, an agentic AI SRE we affectionately call Hawkeye. Now, Hawkeye is targeted at helping solve one of the largest problems that all companies are facing, which is, next slide, a $400 billion price tag. Right now, everyone has dealt with the situation before where you're debugging some obscure problem, you're stuck, you're looking through your logs, your traces, your metrics, your alerts, your config data with 5 different telemetry data like products that you've integrated with that are visualizing different data, transforming different data, and you're lost in the mountain of data that's available to you. And when you're up against the clock with a real fire that needs to be solved as soon as possible, that's a very hard problem to get past. The problems in current debugging aren't that there isn't enough data, it's filtering through all the noise that is there. And this isn't something that's just available just happens once or twice to different SREs. This is a problem that the majority of SREs say is their #1 challenge in their job. 70% of IT teams are using 4 or more observability tools and are still failing at solving these issues in a fast amount of time. And the second biggest challenge is once you're done with your portion of debugging, continuing that conversation with someone on a different team and trying to transfer all the knowledge that you found in your debugging process. So that's where our vision comes in. An AI agent that will step in as a teammate to other SREs that will integrate into their normal day-to-day workflows. This SRE will be able to have an understanding of your company's infrastructure, and with the team that we've built with experts in this kind of debugging fields, we'll be able to use the reasoning power of LLMs to use IT telemetry in a secure and accurate manner. Now, for a quick look at what Hawkeye is able to do in a usual environment, you'll see here that on this screen over here that a PagerDuty incident comes up. It's in your Slack. Everyone's discussing the issue. Hawkeye's immediately on it. And in the video that I would have shown here, you'll be able to see that Hawkeye is showing you a timeline of everything that's happened with the telemetry data that is ingested. It's able to show you evidence on the root cause that is found, find the root cause, and suggest corrective actions, all in the matter of minutes. Now, when our customers have hired Hawkeye, they have been able to, next slide, please. They've been able to use it to cut down their incident response time by 90%. And
I'm sorry, we have to end.
Yeah, so please go to Newbird.ai to see our product. Thank you so much.
Thank you so much. Now we have startup number 6, Virtue AI.
Okay, I love the very strict timing here today. Hi, everyone. I'm Sammy Koyejo. I'm with Virtue AI. Despite all of the great advances in the AI technology and all of the excitement about building and deploying AI, I think consistently what we find is that enterprises find it hard to really deploy in practice. And what Virtue AI believes is that some of what blocks real-world deployment are safety, security, performance gaps that make it hard for enterprises to deploy AI in a way that they can trust and rely on, and so on their customers can trust and rely on. And to that end, Virtue AI builds technology to close safety and security gaps for enterprises. So we do this through a variety of different products. We have a red teaming product that looks for security vulnerabilities and works to block them, guardrails to actually implement these kinds of blocks, and then agent infrastructure that builds on these foundations for agent implementations, specifically targeted at upcoming and emerging agent deployments. So these tools are deployed together. We have a holistic framework around both, again, evaluation, mitigation, so blue and red teaming, and then the agent framework around this to allow for agentic deployments. The red teaming components, so some of our differentiators include the fact that we figured out how to automate a lot of technology around building and deploying and scaling red teaming. So this includes a variety of different algorithmic approaches behind the scenes, a broad coverage around security and safety risks. On the guardrail side, we have some of the best-in-class, or if our customers are to be believed, the actual best-in-class guardrails in terms of speed and performance, including technology to allow for high amounts of customizability, so ease of deploying guardrails in ways that adapt to what enterprises and their customers care about, specifically in terms of the definitions of safety and security. On the agentic side, again, I'll focus on this for this audience. We've expanded our view in terms of a broad coverage of security risk categories, which include various kinds of exploitation issues, tool security issues, various issues around model security, memory manipulation. Again, please come talk to me and maybe look at our website for additional details on some of what we cover. And to this end, we build a variety of different tools to help mitigate these kinds of safety and security issues. So things around malicious use issues, clickjacking kinds of problems. Again, many of security issues that often block what it might look like to deploy AI, particularly agentic AI systems in a modern world. So we've built this technology and scaled it across a variety of different verticals and with a variety of different partners. Excited to talk to you, and if you're interested to learn more about some of the technology we're building. Thank you.
Thank you so much. Next is startup number 7, Themia AI.
All right, cool. Hey, great to meet you all here. I'm really excited here to introduce you to Themia AI today. We are a Bay Area startup that specializes in providing expert AI agents for financial services. And my name is Yuhao, and I currently lead the machine learning team at Themia, and I promise I will time it well today. So what is Themia, and why do we exist? So AI has been growing like really quickly for the last couple of years, but today there's still a big gap in what AI products can offer and what financial experts want. They want AI that can help them generate alpha, like orders of magnitudes faster, that can automate common workflows, and that can cover a broad range of specialized data, but without compromising reliability and quality. And this is exactly what Themia is specialized in. We provide purpose-built AI tools for financial experts that can turbocharge their research and analysis and leverage LLM to help them automate their repetitive workflows. So what's our key product? The first product that we have is called Themia Instant Q&A. Now, this is a platform that can generate quick market and company insights for our users within seconds by leveraging agentic search using our in-house specialized orchestration models over many data sources that we have and that are trustable. And as a result, all the answers that we provide are grounded and also fact-checked by AI before we surfacing it to the user. And to make the tool reliable, we have conducted extensive evaluation using in-house benchmarks that consume over 10,000 expert hours already. And the second key product that we offer today is Themia Agents. Compared to Q&A, Themia Agents leverage reasoning models to provide much deeper and broader analysis and can provide workflow automation in addition to just an answer. Themia Agents leverage more offline processing time and can generate financial reports that are easily 30 to 100 pages long with detailed data and reasoning aggregated over many domain-specific sources. So as of today, Themia is already used by some of the top financial institutions around the world. And we've seen a very high user traction with the product. Our customers, like Morgan Stanley Research and some other top hedge funds, have spoken very highly about the product experience. And every day we're working with our users to make the product experience better. So all of this is supported by a very strong technical team. So we have members from top labs, such as Google Research, Stanford, Meta, and et cetera. And we are supported by well-known organizations such as NEA and individual investors in the AI space. And in addition to the product, our team has also published very impactful research papers as well as technical blog posts. And we welcome you to check this out. And lastly, but also importantly, we hire across all the technical roles, including ML, backend, and product engineering. And you can learn more about us on our website. Thank you. Yeah.
Sorry about that. Thank you so much. Next is Agentic AI, startup number 8.
Good afternoon. My name is Mike Mullaney, and I'm with Zenity. And we are securing agentic AI everywhere. The fact that we've got over 1,000 people in this room today is a testament to the fact that agentic AI world is exploding. Come on. There we go. Not only is the agentic world exploding, it's coming from every direction possible. You're seeing agents from the cloud, from SaaS-based offerings, and also from local models. And what is important is, we've heard this today through and through, is that what makes these agents powerful also makes them risky. They have access to sensitive data. They possess intent and can take action, often without any human interaction or oversight at all. What does this mean? What are companies doing to try and address this problem? Well, traditional models that companies have used historically will not work to solve this problem. You cannot set up perimeters and try and block prompts. It simply does not work. You have to look under the hood to understand what is happening with that agent. They talked about it earlier today in the panel with Glean and Google. It's understanding context, intent, and looking for behavior and anomaly detection that has to be done across agents everywhere. How does Zenity help with that problem? Come on. So at Zenity, what we do is help organizations discover agents. You can't protect what you can't secure. We apply security posture management to ensure common misconfigurations don't expose your data. We secure runtime for defense in depth at runtime, and we protect. We can mitigate threats at runtime for those AI agents. So in short, thank you very much. Zenity is the company that is solving the problems you've been talking about today.
Next is startup number 10, Creatify AI.
Hi everyone, I'm Nadal Wu from Creatify AI. I'm super excited to be here to talk about how AI agent is changing the way we create content in marketing, and how at Creatify, how we build agents to generate video ads at scale. So creative is the top challenge of performance marketing team today, yet it is expensive, slow, and vulnerable to ad fatigue and signal loss. So we build AI agents to produce video creatives at scale that actually drives meaningful conversions and revenue. So this is the core behind our core technology. We build multi-agent orchestration that mirrors a full creation team. So at the core, it is the agent brain that coordinates with LLMs, VLMs, image and video generation models that can go through the process of ideation, design, variance generation, and multi-value testing. It gets real-time feedback, and it can do rapid generative and testing. So this is supposed to be a demo, but I failed to embed the video here, so you're going to trust me that the video is awesome. So the idea is that you start with a product category and images, and then you just translate it into an ad-ready video. But we're not just doing video creations. We are also doing an end-to-end ad system. So this is our product called Creative Testing, and it's the first one that can do generation and testing all in one. So it spots market trends, can do rapid generation, and can automatically optimize all the creatives. As a result, our customer gets better ROIs of their ads, like better CTR and ROAS. So we believe that AI is going to revolutionize advertising, and video creatives should be accessible and scalable, just like code. And we have seen rapid growth. Okay, yeah. So I'd love to connect. Thank you all.
Sorry about that. Next is startup number 12, AGI Inc.
That's it. Let's get that. Cool. Sorry. All right, cool. Great to be here. So we are like a new, I would call it like applied AI lab called AGI Inc. This is a spin-off from my last startup called Multion, which we basically built like one of the first browser AI agents. We are invested by some of the top venture capitalists in the Bay Area, including Anthropic as one of our investors. And we are very interested in like how the future of trustworthy agents will look like. How do you build agents that are very, very trustworthy, super reliable, can do transactions for you? I think if anyone here has seen like all the new launches, like Perplexity just launched Comet, and like OpenAI just launched Agent Zero. They're very interesting, but like it's like they're not very safe. You don't know if you will want to use them, trust them with your credit cards, passwords, so on. We want to change that. So the first thing that we have done so far is release a benchmark called Real, which is like one of the first agent leaderboards where you can benchmark agent reliability, which you can check online. Sorry. Okay. Can you go? Okay.
Next.
Let me finish? Okay.
Sorry,
So
I'm sorry, we have to move on.
Okay, let me just finish it, sorry. The first thing that we've done is like we have Agent Zero.
Next is startup number 13.
You can see our checkout next week. Thank you.
Next is startup number 13, Lyica.ai.
Yep, thanks. Hi, I'm Leo from Graphistry, and actually our second product's Lyica.ai. It's actually fun to be back here at Berkeley after, I don't know, 10, 15 years. So there are about 10 million people in the world who are, I call like people who stare at logs. So some of my customers do stuff like cybersecurity incident response, cyber warfare, misinformation. We're doing like a couple of billion-dollar lawsuits. And actually this weekend, my team's at Black Hat, and we have the most popular training. We have 100 or 200 hackers and red teamers and blue teamers learning how to do agentic work. And actually, I'm a little nervous I'm being here and not there. But given that, we're actually doing two things, Vibes Investigating and agentic automation. And what it comes down to is one side is as analysts deal with all this data, we're just trying to kind of 10x them so that they just get superpowers of doing all this agentic stuff. But the kind of more from the hardcore technology side, what we're really doing is automation. And so like instead of them having to do all this work, how do they do no work? Because they could just automate themselves and do more interesting things. And one very interesting thing that we did earlier this year is we announced the first speed run of an open blue team CTF, the most popular one, Boss of the SOC. So come talk to me after, and I can tell you all about it.
Next is startup 16, Varus AI.
Hey everyone, my name is Mehdi Jami. I'm the co-founder and CEO of Varus AI. At Varus, we are tackling some of the most important problems in deploying AI agents in production and the reliability issues that we've been talking about tonight. Varus is a modern infrastructure for that is purpose-built for agentic systems. And I don't know how to change the. I don't have the. Can you change the? So the infrastructure that we are building is a sandbox environment that's purpose-built for your agent. And in this sandbox, the agent would interact with the simulated users and simulated tools and get feedback from the environment. And then you have a host of different optimization methods from automatic prompt tuning and reinforcement learning to actually improve the agent and teach it to get it better under the metrics that you care about.
Sorry. Next is startup number 17, Lyica World.
Hi, I'm the founder of Lyica. Can we put up the slide, please? So I wanted to, is my time started or not? I'm not sure, but I'm going to say, so I wanted to create a job posting for LinkedIn, and I wanted to create a poster. And also the slides for this particular, next slide, please. And also the slide for this particular presentation. And ChatGPT gave me, next slide. Again, next slide. And these are some of the ChatGPT results that I got. They were really ugly. Our designer was pissed. And he was like, Purvanshi, you cannot use this anywhere. Logo is off, colors are off. So what we are trying to build, next slide, is foundational models, next please, for foundational models for graphic design, where Lyica acts as a graphic designer for every brand. We are giving users highest level of control, and everything that comes out of the model is brand compliant with the right logos and colors. Could you jump to next 3 slides? We are working with a lot of D2C brands like NFL, American Eagle. These are some of our investors. We are hiring across all roles. Talk to me. Thank you.
Next is startup number 18, Themia.
Where's the clicker? There's no clicker. That's right. Hello, this is Stefano from Themia. Can you actually hear me? Great. Can you hear from my voice if I sound tired? or stressed? Can you hear if I am in pain? I bet you can, actually, because as humans, we do pick on cues, not only on what you say, but how you say it. And if you are a trained clinician, you would actually be able to do something more, which is maybe telling something about clinical information. However, voice AI agents, voice AI agents that we try and push today in the clinical world cannot. How do we fix it? With speech biomarkers and clickers. Speech biomarkers is something that we've been building for 5 years at Themia. From 15 seconds of your voice, we can pick nuances about depression, anxiety, now physical health too. We are regulating these and packaging as a medical device and clicker in voice AI agents that can actually act as AI nurses, calling you up in between appointments, and you wait, and during waiting time lists, and I'm here, like, oh, we're both here. And I say, hello, okay, time is up.
Sorry, next is startup number 15, Judgement AI. Great. Thanks, everyone. So great to talk. We're Judgement Labs. Make this pretty simple for you all. I'm Alex from Stanford, did a lot of research in model eval, now working on the agent evaluation space with my co-founders and team. The essential problem that we're trying to solve is that agents are really good in demos, but ultimately break inside of production. And ultimately, we're trying to solve the 80 to 100% last mile gap in terms of agent performance. We are trying to bring a modern toolkit to essentially create the modern CI/CD suite on top of agents, specifically for those that are already in production and want to monitor and optimize inside of production data environments. The way that we do that is we're building an open source kit for post-building on agents. Essentially, imagine all things to do with post-training on agents, but also extrapolated to the hyperparameters on your setups, including your models, model selection, context sharing, and tool selection amongst agents, where you can imagine us as a modern-day Datadog or Sentry-style solution for monitoring things in prod on top of agents. Here's our open source GitHub. Happy to answer any questions. You can reach out to us. We have our contact on the website. Thanks a lot. Next is startup number 19, Nimble Edge.
Hey everyone, this is Varun and he's Neeraj. We are the co-founders of Nimble Edge. We are over here trying to scale AI and make it more accessible and personal.
Hello everyone. We believe AI should be personal, it should be private, and it should be accessible. So it can work seamlessly for my dad, who is nearing 70, and for a kid, who is 3.5 years old, right? We just saw Mr. Khosla, who is, by his ways of saying, he's 70. So maybe with AI, we can have more of Mr. Khoslas. In order to do that, what we have done is build an open source platform that enables AI to run natively on mobile devices and unlock the compute that's available across billions of users.
So we help AI bring the Lyica AI platform that's completely open source. One of the core components is helping you run your LLMs 2 times faster with 50% lesser memory. All of that is open source, along with the Python scripting engine.
Thank you very much. Next is startup number 20, Link Alpha.
All right, can you? Hi, my name is Jacob. I'm the CEO and co-founder of Link Alpha. Link Alpha is the first multi-agent AI platform for institutional investors. We cover like more than 60,000 global stocks and sync with client data. And think like Glean meets Perplexity, but purposely built for investment research. Here's an example. Like you start your morning with a briefing agent that gives you a tailored summary of overnight news and filings. And then if one of your names has an earnings call today, the earnings call agent that tracks the schedule and then delivers a crisp summary. And then finally, a devil's advocate agent reviews the internal slides, models, and the team notes to flag blind spots ahead of your IC meetings. So it's like a full team of portfolio managers and analysts, working 24/7 at the speed of AI. So Link Alpha is built by a world-class team of MIT PhDs and ex-Goldman Sachs analysts, and it's currently used by 170 institutional investors like hedge funds and asset managers. Thank you.
Next is startup number 21, Scrollmark.
Hi, everyone. I'm Akshay, one of the co-founders of Scrollmark, proud UC Berkeley alum, go Bears. We're building social GPT. We're seeing now how much content creation, especially professional content creation, is being democratized with AI photo and video editors. And we've all seen those crazy video generations from VO. And the next challenge here for professional content creators, of which there are 5 million in the US, is how do I create content that's going to get people to stop their scroll? And that's what social GPT is built to do. Technically, we are tracking something like 50 different attributes of video content, things like hook structure and caption density, and using LLMs to tag these different clusters of content that we now know are trends. And using that to kind of tell creators, hey, what should I post that is going to cause people to care and what people can really monetize? If you have any questions, please find me outside. Thank you so much.
Next is startup number 22, Scrollcaster.
No, that's not us.
Oh, sorry. Oh. Raycaster. My apologies.
Hi, everyone. I'm Levi, founder and CEO of Raycaster. First, wanted to say thank you to Berkeley RDI and the amazing sponsors for honoring us as the winner of the Agent X global competition. So thank you for having us here. Every cure that could save a life is trapped in manual paperwork. Even though drug discovery is accelerating, drug development and the infrastructure supporting it are buried in manual paperwork. From RFIs to protocols to batch records, all these are the life science providers that are struggling with to integrate with fragmented systems all the way to coordinate with different humans that take weeks and months into pushing things forward. So we're Raycaster, an agentic AI platform for biopharma operations.
I'm sorry, I cut you off.
Thank you.
Now we have startup number 23, Petronis AI.
Hi, I'm Darshan. I'm a research scientist at Petronis AI. We have probably heard way too many times today that evaluations are very difficult. They're kind of the core problem of agents. And so what we try to do is we take a research-centric approach to evaluations. We build automated evaluators that are backed by memory systems that kind of adapt with your domains, with what your preferences are, because humans are terrible at defining preferences. They're very noisy. And so our core product kind of centers around RL environments that are dynamic. And also we have agents as judges, state-of-the-art research. And yeah, I'm pretty happy to be here and happy to connect afterwards as well. Thank you.
All right, well, that concludes our programming today, but I do want to let you know we have a reception. Some food is on the patio, but most of the reception food is down by the tent, and there are posters there. There are also still posters in the Kerr lobby, so please enjoy the reception food and networking and the posters. Thank you for being with us today. I also wanted to add, we will offer an Agents MOOC again this fall, if you'd like to join that, and we will announce our accelerator that we're offering.